and welcome, I'm your Code Monkey, and welcome to my free course on making a game with Netcode for Entities. This is Unity's super performant toolstack meant for fast-paced, complex multiplayer games. Here, let's make a very simple multiplayer game from scratch. We're going to make a nice tic-tac-toe game. This is very basic in terms of game design, which means this is a great learning project. It means that we can focus just on the netcode itself. And this is actually my second free course. I already made one on making this exact same game, but that one with netcode for game objects, whereas here we will be using netcode for entities. So if you follow the previous one, you should have an easier time following this one too. Netcode for entities might seem a little complex at first, but if you first watch the other one, then it should be easier to understand everything we're going to do, since you will be able to see all the parallels between the two versions, between the two different tech stacks. Netcode for game objects, this is what you want to use if you want to make small-scale co-op games like Among Us, Valheim, Overcooked, and so on. Whereas this one, Netcode for entities, this is the more powerful toolstack. This one is meant for making games like Call of Duty, Apex Legends, Rocket League, League of Legends, Mortal Kombat, and many others. Despite tic-tac-toe being such a basic game, despite that, it still requires us to learn the basics of multiplayer game development. Then of course, once you understand these core basics, once you know how to use netcode for entities, then you can expand upon it to make all kinds of interesting multiplayer games. Here we're going to have a multiplayer connection between two clients, one of them is a host, then each player is going to take their turn to do their action, the data is synchronized to the other player, then once there is either a tie or win, the game ends and we can start again. So yep, in terms of game design, it is super simple, but still requires us to learn quite a lot of things. Then, like I said, afterwards you can expand upon this after you know the basics. Multiplayer games are really just all about synchronizing data. So once you know how to synchronize a simple game like this one, once you know that, then you can easily synchronize more complex data. So afterwards, you'll be able to make multiplayer shooters, multiplayer horror games, action games, strategy games, and so on. Now, here in this course, I'm going to be teaching you everything about netcode for entities. So I will teach everything from scratch, including how to set up the connections, send and receive RPCs, teach you about ghosts, and so on. But I will assume you have some knowledge of dots. So here I assume you know what is an entity, what is a component in the system. If you don't know that, if not, then go watch either my 1-hour tutorial covering an overview of dots, or watch my course on making an RTS game with dots. You can watch those to learn how dots works in single player, and then you will be able to follow this course to learn all about netcode for entities. I also have a 1-hour tutorial doing an overview of netcode for entities, so if you want, you can watch that one or not. Personally, I like watching a high-level overview of an API before I go into some more step-by-step practical guides. So personally, I would watch that one first, but like I said, here I will be teaching everything related to netcode for entities from scratch, so everything covered in that video will also be covered in this video. As long as you know the basics behind Unity dots, as long as you know that, you should be able to follow everything in this course. Okay, so let's look at the final game we're going to build. Alright, so here is the final game we're going to build from scratch in this entire course. So I've got the two windows and both of them are already connected. It's a simple tic-tac-toe game, so I can take an action. Right now it's this player up here taking an action. So I can go ahead, click on any of these grid positions like over here. And if there you go, it places that object, and of course the other player also sees the object being spawned. Now it's this other player's turn, so over here we can take an action, and again, same thing, this one takes an action and spawns the object on both sides. So we can keep taking more and more actions, just like that, and if there you go, over here this player has won, and this one has lost. So the game is over, and now we can click on the Rematch button, start a brand new game, and now we can play again. So we can go down, 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 and yep, the whole thing works nice. Now, despite this being a simple game, here we can already see quite a lot of interesting stuff, quite a lot of data being synchronized. So first of all, obviously the objects. When I place an object, it gets automatically synchronized across the network. Then on the top bar, we can see we are synchronizing the current playable player. So right now it's meant to be the circles player and not the crosses player. Up top we can see on this window, this player is playing crosses and this one down here is playing circles. So it's this the one that can now take an action. Meaning if up here I click, nope, obviously this one cannot take an action, but on this one can click, and if there you go, take an action, it works. Then up top we can also see that we are synchronizing the score, so it's currently 1-1. And when we click on Rematch, everything gets synchronized, so the whole board gets cleared and we are ready to play once again. So yep, here we are synchronizing data for the players, data for the scores, data for which is the current playable player type. We are synchronizing all the rules that make the game work. The whole thing makes sure that the server validates the player actions. So if right now I try taking an action here, it doesn't work, it has to be down here. Then of course it is checking for the win logic, so when we got 3 in a row, we have winner, and on this side we have loser. In order to make all this work, we are synchronizing some ghosts, these are the objects. We are synchronizing some ghost fields for the custom data. We are synchronizing some RPCs. We are testing for which are the connected clients, what is their connected client ID, and a bunch more. So yep, despite being a simple game, here we are still using quite a lot of very interesting multiplayer stuff. And then we also implement lobby and relay. So lobby, this is how we can create various lobbies, then we can join them. And we have relay, meaning that the game can be played throughout the internet and avoids any issues with either firewalls or not. So any player anywhere in the world can create the lobby, join the lobby, they can connect together, and everything works flawlessly. Yep, that's our final game. Now, there are project files and assets downloadable from the link description. All of that is completely free. There's also a premium version of this course, although there's no knowledge and no project files behind a paywall. All of that is completely free. You don't have to pay 1 cent to learn this knowledge. But if you can't afford it, if you do have a few bucks to spare, if so, then the premium version has some really nice bonuses. First of all, obviously it has no YouTube ads, so nothing to interrupt your learning process. Then it also grants you access to my private Discord and private live streams. I do those every week and I'm there to answer whatever questions you have or really just chat. Then the premium version also has priority QA, meaning I'm going to be answering the questions on that version first, but I will still be answering as many comments as I can over here on this video. The premium version also has a really nice companion project. This contains frequently asked questions and quizzes for each lecture in the course. These help truly reinforce what you're learning. If you make the effort to pay attention in the course, you should be able to answer all of these correctly, which will ensure you're actually really learning. If you take the time to go through all of these and get 100%, if so, then you will gain all this knowledge. You should watch the video lectures, then go on to the companion project, read the summary of the lecture, do all the FAQs and the quizzes. Always remember how you only truly learn if you actually put into practice what you're learning. You don't learn just by blindly watching a video. So this companion project is meant to do exactly that, meant to put your knowledge to the test so you make sure you're actually learning. Then the next bonus is the CodeBank companion window. So this window keeps track of your project, and if it encounters any errors, it will help guide you in the right direction. Another nice window is Chat with AI. Like the name implies, this lets you chat with an AI that was trained on the contents of the course. It's a great way to get some help pretty much instantly so you never get stuck. Alternatively, when you post in the course comment section, you'll get a near instant reply also from this AI. This is also great for another quick help, but again, I will also manually be answering myself within the next 24 hours. So yep, these are the bonuses for the premium version. If you can afford it, that's awesome, that's really cool. You get some really nice bonuses to help you truly learn. If you are serious and committed to learning, I really recommend you get it. And if just a tiny percentage of people watching this video picks up the premium version, if so, then I can keep making free courses and that would be awesome. So if you can afford it, that's great, thank you, and I hope you learn a lot. But if you can't afford it, then that's fine too. Like I said, all the knowledge is completely free right here in this video. You really just need to put in a bit more effort yourself in order to guide you to make sure you're truly learning. Whereas on the premium version, you just have to follow the path that I have pre-prepared for you. So here I just ask you to subscribe to the channel and like this video. It's a tiny thing, but it really does help. Oh, and if you want to stay up to date with all the game dev news and interesting articles, then subscribe to my free weekly Game Dev Report newsletter. This is where I cover lots of interesting stories that help you stay up to date and keep on learning. So check it out and sign up for free. Alright, so that's the intro out of the way. Now let's go on to the next lecture where we're going to see a complete overview of the entire course from start to finish. Okay, so here's everything we're going to learn throughout this course. Every step we're going to take from the very beginning until the very end. We're going to start off completely from scratch, start off by creating a brand new empty project using Unity 6 and URP. Then we're going to install all the packages like Netcode for entities and a few more. And finally import the visual assets we're going to use in this course. Then to test our simple connection, we're going to do the most basic thing possible, send and receive an RPC. These are very simple messages. We're going to define the RPC, make a client system to send it, and a server system to receive it. Once we learn about RPCs, then we can learn about the concept of InGame in Netcode for entities. This is how we can mark a connection as being ready to receive constant data, like object spawning or a transform position. Then we're going to build our grid, just a simple 3x3 grid. We're going to make the visuals and also the clickable grid positions. This is actually a very interesting lecture because we're working in dots, so we need to learn about dots physics, which also has some really interesting quirks when combined with Netcode for entities. Next, we create a GameServerSystem and learn how to spawn some ghosts. These are objects that are automatically synchronized across the network. We spawn them on the server and all the clients immediately see them. Then we define the concept of a player type. We have crosses and circles. Using that, we can make it so that each player plays a different type. We're going to assign the type based on the connection ID. Then for something very important, we're going to create a dots event system. Dots is all about data-oriented design, so we cannot use normal C# events since those are objects, so we need to be clever to implement a dots-capable event system. Thanks to that event system, then we are going to set up a canvas and build a UI using normal game objects. Again, even when you make dots games, the UI is usually better made with game objects. So we're going to make that and then use events and dots queries in order to update it. After that, we handle the logic for starting the game. The server checks if we have 2 connected clients, and if so, it starts the game. In doing so, we also update the UI to show the current player type. Then we learn about ghost fields. This one is also very important. This is how we can synchronize custom data at all times. Similar to how the transform data is automatically synchronized, with this we can synchronize any custom data we want. Next, we set up an array to keep track of all our grid positions and what players are where. This way we can prevent players from taking actions on already occupied positions. Then we create the test winner function. The logic in this game is pretty simple. We just check if we have 3 matching symbols in a row. If so, we have a winner. Then we create a GameOverUI to display the player that someone has won or lost. We use RPCs to tell the client that the game has ended. Then we implement a rematch function. The players can ask the server to start a new match. The server then resets the board and destroys all the visuals in order to start a brand new game. After that, we also handle the tie scenario. The game can end in a tie if all positions are occupied and there's no winner. Then we implement a persistent score to keep track of how many wins each player has. This is pretty easy, we just need to use some ghost fields. Next, we add some sound effects and music. Also pretty basic, we just spawn some objects that automatically play a sound. And then we implement lobby and relay. These are two very important Unity tools for making our game easily playable. Lobby lets us group players together, and relay helps them connect to each other without issues with firewalls or net. Then we do a bunch of tiny things to polish up the game, adding some nice visuals, nice effects. And after all that, we will have our final polished game. The whole thing working really nicely, and all of it working in multiplayer using Netcode for entities. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to get started making our project, set up Unity, and install all the packages. By the way, here in this lecture, we are going to be creating a brand new empty project and installing a bunch of packages and setting the whole thing up. If you want, you can follow along. Or a much better approach is to just watch this entire lecture, and at the end just download the project files. By doing that, you will have the exact same versions and everything exactly the same as I have over here. So to avoid any issues, I highly recommend you do that. Just watch this lecture and then at the end, download those project files. Alright, so let's create a brand new project. So here I'm going to be using Unity 6, I've got this version installed. And we're going to be using the Universal 3D template. Even though this game is actually going to be in 2D, Dots doesn't yet support 2D natively. So we are going to be using flat 2D meshes, but we are going to be using the 3D URP template. So let's go ahead, select this template. Let's give it a name, like Tic Tac Toe Netcode Entities. Let's leave the cloud connection enabled, so later on we can use lobby and relay and so on. And yep, let's go ahead and create. Okay, yep, so here is our completely brand new empty project. Now let's just go ahead and remove these readme assets. And let's also go ahead and rename our scene. Make this the game scene, just like this. Now, in order to make multiplayer games, here we are going to be using Netcode for entities. This is Unity's own networking toolstack. This is the super performant one, meant for fast-paced, complex multiplayer games. It is built on top of their entities dots toolstack. So let's go ahead and install, go up in the package manager. Then here on the left side, let's go on the Unity registry. And let's scroll down to find the Netcode for entities package. So yep, here it is, this one. Although, right now, at the time of this recording, it says that the latest version is 1.3.6. However, on the official manual, the latest version is 1.4. Now, I'm not entirely sure why this one doesn't show up on the package manager. Maybe they're just polishing a few things and they're going to add it later. But either way, I'm going to be installing that one since that one is the latest stable release. Since it doesn't show up in here, let's go ahead through this, install package by name, com.unity.netcode. And then for the version, 1.4.0. So yep, let's install. Now, if you're following along, I highly recommend you use the exact same version as me. If you use a different version, the syntax might be slightly different. Like I mentioned, you can also download the starting project files. I've included a brand new empty project with just the packages installed and the visual assets. So if you start from those project files, you are guaranteed to be using the exact same versions as me. If you do that, then everything will match up exactly the same as you see over here in this video. Okay, so yep, we've installed the package. And over here we can see it also installed a bunch of dependencies, namely the entities. Like I said, this Netcode for entities, this one runs on top of entities, meaning it also works with dots. So over here, it also installed bursts, collections, mathematics, and so on. So we already have all of these packages. And then since we are going to be rendering our objects using entities, let's also install over here the entities graphics package. And then down here, we are also going to be using physics. So let's also select Unity Physics like this. So yep, let's go ahead and install both these. So here are the versions. Okay, great, so all of those are installed. Finally, let's follow the recommendations from the entities package. So first of all, we should be using a recommend IDE. So over here they recommend either Visual Studio or Writer. This has to do with how Dots has a lot of source generation, so it needs to have an IDE that does support that. Over here I'm going to be using Visual Studio 22. And then we should also set up this, the domain reload setting. So in our project, let's go to Edit, then Project Settings. And over here, let's find the Editor tab, then let's scroll all the way to the bottom. And yep, over here, the Interplay Mode settings. Let's swap this one to Do Not Reload Domain or Scene. Okay, great, just like this. By the way, do be aware of what exactly does this mean. This makes it quite a bit faster to go into play mode, which is awesome. But do keep in mind this note. So if you disable domain reloads, which we did, if so, then be mindful of your use of static fields and static event handlers. Basically, when you have domain reload enabled, when you have that, if you have any static fields or static event handlers, those will be reset when the domain reloads. But if we disable this, then this data will not be reset every time we stop playing the game. So always keep that in mind. If you have static fields, they will not reset automatically between stopping and playing the game again. But as long as you keep that in mind, yep, this is a great setting. It makes everything quite a bit faster. Okay, so we have the basics. Now, first let's actually handle our multiplayer connection before we even build any kind of logic specific to our game. Let's do that just to see how easy it is to create a simple and bare bones connection. We can begin by actually verifying that everything did install correctly. So over here, let's hit on play. And now let's go up here into Window, then go into Entities, and let's open up the hierarchy window. So this is the entities hierarchy. And over here, we have a drop-down menu for selecting the world. And yep, right away, we can see we do have two worlds. We've got a server world and a client world. So like the name implies, over here on the server world, this one is where the server is going to run, and the client, this is where the client runs. This is how Netcode for entities handles that separation. It is all completely separated in two separate different worlds. This is the default setup. So by default, it automatically creates a server world and a client world, meaning by default, it's actually creating a host. So that means we should also learn about the various network topologies. When it comes to making multiplayer games, we have several options. So one option is a client-server topology. On this one, we have a dedicated game server and then just normal clients. Then the other alternative is to have a client-hosted listened server. So that means one of the clients is going to be both client and server. It's going to be a host, and all the others act as just normal clients. So for the three types that we have server, we have client, and we have host. Now for those, what those mean, the server, that means literally just a server, so there's no player controlling it. This is just a dedicated server. Then for the client, this is what the players use. It is what they use to connect to the server and actually play. And then we have the host, and this one is basically a combination. It is server plus client. So the host over here, this one can control a player, it can actually play the game, and this one is also running the server. This one is default. This is what we just saw. It automatically created both a server and a client world, so we are running a host by default. Basically, if you want your game to be using dedicated servers, if so, then you would just make a server build and then a client build for all your players. Alternatively, if you want your game to be client hosted, like for example most co-op games, that way you don't need dedicated servers, and for this one you would have just one player act as a host, and all the others would just be clients. This one over here, client hosted, this is the simplest network topology. Basically, you don't need any servers, any cloud, anything like that. Really just need one of the players to act as a host and everyone else connects to it. This is the simplest one, so this is what we're going to use. And of course, you can use this for testing just to make it easier, and then later on, you can just make a dedicated server. Thanks to how Netcode for entities nicely decouples the server and client worlds, because that you can easily make pretty much any kind of build. So you can test with just a host, and then later on make a dedicated server. Okay, so yep, by default, our game is already set up as a host, meaning we have both a server and a client. This is exactly what we want right now. And now if we test out making a scene, so let's first of all just keep this entities hierarchy, sometimes it's useful, so let's put it over there. Let's stop playing, and then over here on the normal scene, let's right click, let's create a brand new empty subscene. On this one, let's name it the game subscene. So this is a dot subscene. Inside of this one, if we place some kind of object, like let's say we're going to place just a normal cube. So there it is, we have a normal cube that exists inside of our subscene. And if we hit on play, and over here we check the entities hierarchy, yep, that cube exists both on the server world and also on the client world. So yep, any objects that we place over here by default, they will spawn on both the server and the client. However, actually one very important thing, which is over here we can see we are creating two worlds, so that's great. However, this is not actually starting a connection. Right now this is still completely offline, so we need to start the connection manually. We can actually verify that we are indeed disconnected by looking for an entity. So let's go on either of these worlds, doesn't matter. Let's say on the server world. Over here, let's add a filter. Let's look for a component of type network ID. Yep, this network ID component. And if we search, nope, no items matches our search. This component, this is the one that actually handles a connection. And this one does not exist because we are currently disconnected. There is no connection anywhere right now. The server is not listening to anything and the client is not connected to anything. So yep, let's do that. Let's connect. Later on, we're going to see how to make some buttons to start the server and connect. But for testing, we can actually use the built-in auto-connect feature that is super simple. For that, let's just go ahead and stop playing the game. And we're going to need to create a script. So first, let's make a nice folder for our scripts. So our scripts folder. And then inside, let's create a new, let's make a standard monobehavior script. Let's call this the game bootstrap. And on this one, let's get rid of all of this code. And we are not going to extend monobehavior. Instead, we're going to extend the client server bootstrap. This one over here that exists in namespace unity.netcode. So yep, let's add the netcode, and over here let's extend this class. And now we can override the initialize function. So that's public override. Let's override this one, the initialize. So this one is a bool, initialize, takes in a default world name. And on this one, we should just assign the auto connect port. So auto connect port, let's assign this one. We can assign to any port we want. And by default, Unity suggests that Netcode for Entities runs on port 7979, so let's use exactly that. And yep, so it's just like this. Just one more thing, according to the docs, up here we should add an attribute, so let's add the Unity engine.scripting.preserve. Okay, so yep, so this is our nice game bootstrap script, and we don't even need to do anything. This one is not a model behavior, so we don't need to attach this to any game object or anything. As long as this script exists, everything will work. So this should be automatically bootstrapping our game and starting the connection. So let's go ahead and save this. Let's wait for it to compile and let's test. So as soon as we hit on play, actually you do see a nice helpful error. So it's telling us Netcode detected you don't have application.run in background enabled. Now this is actually required for multiplayer games. Otherwise, if this wasn't enabled, if so, then basically the game freezes when you alt-tab out of it. So if you did that in a multiplayer game, it would basically time out the connection if you just swapped windows. So let's go ahead and set that up. That is very simple. Just go in Edit, then Project Settings. Then over here, let's go down into the Player tab. And then let's take this one, the run in background like this. So yep, just like this, and let's test again. And if there it is, now it's running, no errors. And once again, now we can verify we are connected. So over here on the entities hierarchy, let's look. And let's look for a type. And for the type, let's look for a network ID. And if there you go, now over here on the server world, we can indeed find one. We find network connection, so on the inspector, let's put it in runtime mode. And if there it is, here it is, we can see it working. Here we have the network ID, so this one is connecting with a value of 1. And same thing on the other side, so over here on the server world, yep, it has that one. And same thing on the client world. This one also has network connection, so we can see this one is connected to the server, and the server is connected to the client. Alright, awesome. So that's great, the basics are working, we have a basic connection. Except obviously we don't see anything happen. All we have right now is just a host. So let's connect the client. And for that, basically we're going to need a second window. One way to do that is to make a normal build. But before we do that, let's actually set up one thing that is very important since we are using the automatic bootstrapper. Let's go over here into Edit, then down into Project Settings. And then over here on the left side, we've got Multiplayer, and inside we've got the build. So up here we have the Netcode client target. Here we can define how the build will behave according to the automatic bootstrapper. So we can make it behave as either a client and server, meaning a host, or just a normal client. Now in our case, we're going to make the build be just a client, and then over here in the editor, we're going to run the server. So let's go ahead and select this one, we can close, and now we can make our build. So we can go into the build profiles. And over here, yep, I'm going to make a simple, normal Windows build. So let's just go ahead, build and run. Okay, let's go ahead and save. And yep, it's building, so let's wait. It's still building, so let's keep waiting. Okay, it's still building, so let's keep waiting. Okay, so finally here is the build running. Now we can go here in the editor. And now the way that we define how the editor works, that one is with another window. So let's go up here into window. Let's go into multiplayer and then open up the play mode tools. So here it is, this nice window. Let's anchor it over here on the bottom. Yep, we have this one. Now here we have a whole bunch of settings so we can simulate lag, spikes, and so on. Right now we don't care about those. All we care about is just this one, the play mode type. So this one is going to define how the editor window works. Now, since we made the build a client, let's make sure over here the editor, this one is marked as client and server. Also, by the way, there's one thing here that I'm not sure if it's a visual Unity bug or if it's actually intended. So over here, we just see this one drop-down menu, just this one. However, if we go back into the edit, the project files, if we go over here on the same build, and over here we swap this one from client and we swap to client and server, let's see what happens over there. If there you go, all of a sudden that one shows up like a server emulation drop-down menu. Again, I'm not sure if this is a visual bug or intended. I'm not sure why this setting would impact this setting over here. I would assume this one should be dependent on this one and not this one, but anyways. Either one like this, we can see both, so we can close this, and yep, make this one a client and server. So that way the editor is going to be a server, and then over here our build is going to be just a client, so if we run both, and yep, it works. So here this one is a client, this one over here is acting as a server, and yep, those are both connected. So that's great, so we have this client window connected to the host window. So we can create an executable whenever we want to test, whenever we want to create a client to connect to the host and so on. However, making a build, that takes quite a bit of time, so that process is quite slow for multiplayer development. Iteration is something you always want to be as fast as possible. If it takes over 2 minutes to make a build every time you want to test something, then that's really not very nice. Now, thankfully, Unity has recently made a really awesome package to help solve just that problem. So let's open up the window, the package manager, and over here, let's scroll down and find over here this one, the multiplayer play mode package. So yep, here's the version, let's go ahead and install. Okay, it's installed. So now we can go up here into window, then go into multiplayer, and yep, we have this one, the multiplayer play mode. So that opens up this window. This one is super simple and really powerful. Let's just go ahead and dock it down here. So you have the multiplayer play mode window. Over here, we really just have these checkboxes. So if you go ahead and click this one, and if there you go, this one is now activating, it is now spawning a brand new Unity instance. So yep, here it is. We have basically a second Unity window. And on this one, on the top right corner, we have this layout button and we can enable the play mode tool. So let's go ahead and apply. And yep, over here we do see those buttons. So now, for example, on this second window, let's make this one just a client. And then on the main window, on the play mode tools, let's make it a client and a server. So yep, we have both these, and now all we need to do is just hit on play. And as soon as you do, yep, it starts playing on both windows automatically. And right away, since we have the bootstrapper, both of them are already connected. If you look over here on the server world, look for a network ID, we can see, yep, we do have these two connections. So yep, as you can see, this is super great. We really just click on play and everything starts playing automatically. So it doesn't take 2 minutes to create a brand new build, literally just takes 2 to 3 seconds. We do that and everything is automatically connected, so we can verify everything is working. Also, the second window has easy access over here to console, which is also going to be very helpful for seeing what exactly is happening on this side. So yep, this multiplayer play mode package, this one is really awesome. It makes multiplayer iteration much faster. You can spawn up to 3 instances and test them out. Alright, so here we have a multiplayer connection currently running, except not really, at least not fully. It is connected right now, but right now in this mode, all we can do are really just send RPCs. Like this, we cannot yet send any constant data like a transform position. In order to synchronize that data, we're going to need to learn about the concept of InGame. And in order to learn about the concept of InGame, first we need to learn about RPCs. So let's begin learning about those in the next lecture. But before we end this one, let's first import the visual assets we're going to use in this course. There's a download link in this lecture. It's a zip file and inside contains a Unity package with all the assets. So here it is, let's just drag this one onto our project. And yep, here it is, pretty simple. Really just has a bunch of visuals, bunch of sound effects and music, and a bunch of materials. So let's go ahead, make sure everything is selected and import. And yep, here we have all our windows with all the assets we're going to need to make this entire game. Finally, over here for the Visual Studio setup, in the downloadable files, you can also download my Visual Studio settings, the VS settings. So you can download those, and then over here go into Tools, and go into Import and Export Settings, and then yep, click on Import and just import that file. That way you get everything working exactly as I have. And secondly, I also have an interesting extension installed. So up here into Extensions, Manage Extensions. So yep, this is one that I have installed via Sphora. This one just adds a bunch of nice colors, so personally I quite like it. This is not a requirement, so you don't have to, but if you want, go ahead and install this one. And then this one also has some settings. So on the files, you also have this one, the vsphora.xml. So you can go up into Tools, go into Options, then over here scroll down and find vsphora. And inside vsphora, yep, here there's an Export Import menu. Just go ahead, import settings, and import that file. So yep, if you want your Visual Studio to look exactly like mine, then go ahead and do that. And now is the time for you to download the full project files for this lecture. That way you get the exact same project that I have over here with all the exact same version numbers. So if you start from those project files, everything will look exactly like what you're seeing in this video in this entire course. Using the same project files is really the best way to ensure you can follow everything in this course without any issues. Okay, so go ahead and grab those, set up your own project, and let's keep going to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to install the companion package and go through it. Okay, so the premium version of this course comes with a nice companion package. If you're on the premium version, then check out the download area for this lecture to download this package. If you're watching the free YouTube video, then I'll tell you what you can do instead in a little bit. So go ahead, download the package, and then just import it into a project. You can either import it onto a completely empty project, or onto the actual project you're following along with this course. Either way works, this companion package does not interfere with anything. So yep, here's the package, just go ahead, select everything and import. And here it is, I've installed it onto this empty project. Now this one contains a bunch of nice helper windows to help you truly learn the contents of each lecture. You can access all those windows by going to the top and you see this Code Monkey menu. And over here, let's start off with the Code Monkey main window. So yep, here it is, there's this window, you can dock it anywhere, so let's dock it right there. Yep, this is the main window, it's got a bunch of normal info, and then inside you've got the lecture list with buttons for each lecture in this course. Then inside each of these lectures, you have both a summary for what we learned in that lecture, and then buttons over here, one for the FAQs, for the frequently asked questions. So that opens up this window, so let's go ahead and put it over there. And then another one for the quizzes, also opens up this window, so you can also go ahead, put it over there. So basically the goal is, after you watch each lecture, after that, what you should do is go through every one of these. So go on to the lecture list, click on it, select the lecture that you just got through. So let's say the Getting Started lecture, we just saw this one. So come here, then read the summary to get a refresher of everything we learned in this lecture. By the way, this summary over here, this one is also available on the lecture page if you prefer reading there. So read the summary, then go through all the quizzes, and go through every single one of these. So these are all various questions. So for example, this one, why does this project use a 3D universal template instead of a 2D template? So go ahead, select that. That's a question. So what is the answer? Is because 2D is not supported in Unity 6? Is because dots does not yet natively support 2D? Is because this game requires 3D physics? Or is because the 3D template is faster than the 2D template? If you paid attention to everything I mentioned in the lecture, you should be able to answer this correctly. And the answer is dots does not yet natively support 2D. That is why we use the 3D universal template. So if there it is, that's the correct answer. If you got it wrong, it just shows in red and shows you what is the correct answer. And then over here, the answer provides some more extra detail. So in this case, dots does not natively support 2D. So the project uses flat 2D quad meshes with a 3D URP template. So if you can do that, then click on next to go into the next question, or just go back and select another one from here. And same thing for the frequently asked questions. For example, why are we using Netcode for entities in this project? And here it is. The answer is because the high performance networking tool, the one that is designed for fast-paced complex multiplayer games. And yep, once again, you can click on next to go on to the next question, or go back and select it. Then when you do, you can see you've gone through these. You can see a nice little tick. And over there, you can see, yep, 2 out of 9 and 1 out of 10. And if you go back onto the main menu, over there you can see, yep, 2 out of 109 and 1 out of 137. So yep, basically all of these questions, all of these quizzes, you should be able to get all of these right. If not, then maybe go rewatch the lecture or write some code yourself. Or there's also another nice window. So if you go under CodeMonkey, over here you've got the Chat with AI window. So this one lets you chat with an AI that has been trained on the content of the course. So if you have some questions, you can just come up here, ask a question to the AI, and after about 5 seconds, it will give you an answer. And since it was trained on the content of the course, it should be very good. Alternatively, of course, you can just post in the comments and I will answer myself within the next 24 hours. And if you are writing some code yourself in order to try to fully understand the content of each lecture, if so, and you come across some errors, you also have the companion window. This one over here, this one is basically constantly listening to a bunch of errors that might show up in the console. And if it does detect an error, it will show up some message that might help you solve that error. So usually for these two, I like to dock them down here, that one there, that one there. Yep, just like this. Again, remember, the only goal is really that you're learning. So make sure you put into practice to ensure you're really actually learning. Make sure you go through all the quizzes, all the frequently asked questions for each lecture in the course. Make sure you do this process for every single lecture. And by the end of the entire course, you should have all of these 100% completed. If you put in the effort to go through all of this, then you will truly learn the concepts of this course, and you will truly gain the ability to make any multiplayer game you can think of. So I highly recommend you go through all of these after every single lecture. And if you're following along in the free YouTube video, if so, you can still do this. You don't have access to this companion project, but at the end of every lecture, I made sure to include a screen containing the titles for all the quizzes and all the FAQs. So if you're watching the free version, you can use those to guide yourself in your learning journey. You can go on Google and try to find the answers to all those questions. So if you can't afford the premium version, then that's awesome. You have a very easy guided path that I have pre-prepared for you. All you have to do is just follow the path and you will gain a ton of knowledge. But if you can't afford it, then that's fine. You really just need to put in a bit more work yourself in order to find the answers to these questions that show up at the end of every lecture. Alright, so yep, remember to do this after every lecture, and let's keep going on to the next one. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn all about RPCs. This is the simplest way to send a message to the server or the client. Okay, so technically we have a connection established. So in this main window is set to client and server, this one is just client. If I hit on play, then yep, both of them are going to play and both of them are actually going to connect. So they are indeed connected, but they're in a very limited connection state. Right now, all we can do is just send and receive RPCs. For synchronizing some constant data, like a transform position, for that we need to set the connection as in-game. And before we learn how to do that, first we need to learn how to send some RPCs. So first of all, what are they? RPC stands for Remote Procedure Calls. Basically, it's how you can send a simple message. You can send it from client to server or vice versa. We have basically two possible ways of sending RPCs. So any client can send a message to the server, and then the server can send a message to either all the clients or each individual client. However, clients themselves cannot send RPCs to one another. As to how we do this, it's actually very simple. So first we define the RPC script. So let's first make a folder inside our scripts folder. Let's make it for our RPCs. And then inside, let's create a brand new model behavior script called just a simple RPC. And yep, now on this one, it's going to be very simple. Instead of model behavior, for this one, we're going to implement IRPC command. Yep, this one that exists inside unity.netcode. So that's it. This one doesn't require us to implement any function or anything. Just like this is already an RPC. And then inside, we can add whatever that we want to send with this RPC. We can send nothing, we can send just the RPC, or we can send some data, let's say for example a public int value. And importantly, the RPC needs to be marked as a struct. So yep, that's it. Here we have defined our super simple RPC. Like I said, an RPC is really just a message, and this is the message that we're going to send from one side to the next. We can define whatever that we want inside of this, and on the other side we can receive this same message. Okay, so now let's see how to do that. How do we have the client send this RPC towards the server? For that, let's make two things. Let's make a client system and a server system. So before that, let's actually make a folder for our systems. So new folder for all these systems. And then inside, let's create this template, the entities iSystem. Let's create this one. Call it the test netcode entities client system. Yep, so here is the default template. In order to make this one a client system, for that, we add an attribute to the struct itself. And the attribute is this one, the world system filter. This one takes in a parameter. So this is where we can define the flags. And for making this one run just on the client, for this one we use this one, the client simulation. However, by the way, for clients, there's actually another one we can add. This one, the thin client simulation. Thin clients are really great for testing. They're basically just like clients, but without any rendering. So like I said, these are really great for testing. And usually when you want to define a system as being a client system, usually you want them to run on both clients and thin clients. So for that, you define this one with a client simulation, or just one pipe, so just a bitwise or going to the flag for the thin client simulation. So if that's it, just by adding this attribute, that makes it so that this system is only going to run on clients, it does not run on servers. So now let's make the other system. So make another new entities iSystem for the test netcode entities server system. And on this one, we use the same thing, so let's use a world system filter, except in this case, this one's going to be a server simulation, meaning this one only runs on the server. So yeah, this is extremely important. As we make multiplayer games, it is very important to know what is running on the server and what is running on the client. So we're going to use this quite a lot in order to make sure these systems only run on the server and these only run on the client. Now we can actually verify this. So over here, if we play the game, and if we go into Window, Entities, and let's open up the Systems window. And over here on this one, yep, this one shows all the systems that are currently running. And up here, we can select the world. So we are currently on the server world. And if we look over here, yep, we do see this one, the test netcode entities server system. So this one is over here running on the server world. But yep, we do not see the client system. That's exactly as intended. And if we go on the client world, and on this one, let's expand. And yep, this one does have the test netcode, the client system, but does not have the server system. So yep, by using these attributes, this is how we can define what systems run on the server and what systems run on the clients. Okay, so we have these two, and now over here on the client system, on this one, let's do an update. And on update, let's just test for a key input and send out a simple RPC. So first for the key input, let's do a simple input, get key down, let's say the T key. So when we press on T, we want to send an RPC. And the way we send an RPC is actually quite easy. We really just need to create an entity and attach our component. Again, I covered all of this in detail in my dots course. So what is an entity, how to create one, how to add the component, and so on. Here I'm assuming you know everything about dots other than the netcode part. If you don't yet know that, then go ahead and watch my free dots course. So here, let's just create a brand new entity. So let's access the state, the entity manager, in order to create an entity. So create an entity, so entity for the RPC entity. And then we can go on the state, entity manager, and let's add component data. Let's add it onto this RPC entity, and we're going to add our very simple RPC. And again, like I said, RPCs can either have extra data or no. If we didn't want to pass in any extra data, we would just do this. But if we do, let's go on the value and pass in whatever data we want. So that's it. So we create an entity and attach our RPC component. And importantly, we're also going to need to add the state entity manager. Let's add the component on the same RPC entity, and we want to add the special one, the send RPC command request. So yep, this one over here, which exists inside using unity.netcode. So yep, this is the component that is actually consumed by the RPC system to actually send this RPC. And over here on this one, we actually have some extra data, some extra optional data that we might be able to send. We have a target connection. Like I said, RPCs, the client can only send RPCs to the server, but the server can either send to all the clients or to just one client individual. So this target connection is exactly how you do that. If you assign this to a specific connection, then it just goes to that one specific client. But if not, if we just use this, just without any extra data, if we don't include any specifics, then by default the client will send to the server, and the server by default will send to every single client. But also, like I said, clients cannot send RPCs to other clients. So over here, when working with a client, this one over here is running on the client system. For this one, target connection does not matter. Clients can only send RPCs to the server. So no matter what, this client RPC will always go just to the server. Okay, so yep, so just like this, very simple. So we create an entity, we add our custom RPC component, and we add the send RPC command request. So this is going to send RPC whenever we press the T key. And over here on the server system, let's just listen to it. So let's go on the update. And the way that we listen is super simple. It is basically going to show up as an entity with that component. So to listen to it, we really just do a basic query. So system API, doing a query. Let's do a refro to read our simple RPC. So let's grab that one, and then also refro for the receive RPC command request. This one inside unity.netcode. So this is basically the other side of the C command request. So we have the query for these two, and then on the query, let's also add with entity access, since we are going to need to include the entity so we can then clean it up. So yep, let's put this query inside a for each. So for each, the ref RO for the simple RPC. We've got the simple RPC. Then we've got the ref RO for the receive RPC command request. So you have those in that query. And of course, we have the entity as well. Okay, so yep, so this is our query. And then over here, we can just read our RPC. So let's do a log just to see what it says. So let's use the debug.log inside Unity engine. So let's do a log saying we got an RPC. And inside, we can go inside the simple RPC. We can access the value RO and then read the value that we passed. And let's also print the entity that this RPC is attached to. So the entity. And then finally, let's also print the connection from where this one came from. So for that, we can go inside the receive RPC command request. Let's read the value. And inside, we've got this one, the source connection. This one, as you can see, is of type entity. Like we saw on the other side when sending the RPC for the target is an entity. So this is exactly that. This is going to tell us the entity that contains the connection of the client that sent this RPC. So yep, here we can read any kind of data, whatever we want from our RPC. And finally, let's destroy this entity. So let's actually make an entity command buffer. Entity command buffer, let's construct a brand new one. We can use the allocator.temp. And then at the end, we can do the playback with state.entityManager. And then over here on the entity command buffer, we can call destroy entity and pass in this entity. This is a very, very important thing. We absolutely need to destroy the RPC after receiving it, otherwise we get an error. The RPC should not stay alive for more than one frame. So we read the RPC, we do whatever we want with it, and then we destroy it and everything keeps going. Alright, so yep, so that's really it. So like this, over here on the client system, when we press this button, it is going to create an entity, attach the RPC, and send it. And on the other side, on the server, that one is automatically going to receive the RPC, then it's going to run this query. It is going to find the simple RPC with the receive RPC command request, then it's going to print some data, destroy the RPC, and that's it. So with this, we should be able to send an RPC on the client and receive it on the server. So yep, let's save both files and let's test. Okay, so here we are on this one on the host, so client and server. If we press the T key, and if there we go, there's the RPC. So we can see the RPC inside has the value 56, and it came from this entity. So this is the entity that contains the RPC, this one that was created and then destroyed. And then this entity over here, this one is the one that contains the actual connection. We can see on the entities hierarchy, on the server world, we can look for the network ID. So yep, here we can see two connections, and we can verify this one is probably going to be the 3541, and if there it is, index 3541. So we can see this RPC was sent by this client. And on the other side, on this one, we can press the T key, and if there you go, as soon as we press, yep, over there on the server, it received an RPC. And this one, we can see the RPC ID, that one is a different one. And you can see over there, it also came from different connection. So 3553, which yep, does happen to be this one, the network connection 2. Yep, that is a connection to this client over here. All right, awesome. So here we can press a button and send RPCs, and they can be read on the other side. Okay, so that's great. So here we have the most basic data connection possible. Just a simple RPC being sent and received on the other side whenever we press any kind of button. So that's great, but like I said, right now the game is only in a limited connection state. All we can do right now is really just this, just send and receive RPCs. We cannot yet synchronize any constant data, like for example a transform position, that right now does not work. In order to do that, we need to learn about the concept of in-game. In order to go in-game, we're going to need to use an RPC which we already learned about. So let's learn how to mark the connection as in-game in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the concept of in-game in Netcode for entities, which will allow us to synchronize some constant data. Okay, so like I said, technically we do already have a connection established. We have this second window as a client, the main window as a client and server, and technically right now both windows are connected, but it's only connected in a very limited state. So I can press a button to send an RPC, and yep, there you go, over here on the client, both host and server, this one sends and receives the RPC, and if I go here, press the button, yep, there you go, sends the RPC, and the server receives it. So that's great, but right now we cannot synchronize, for example, transform data. In order to synchronize that kind of data, we need to first learn about the concept of in-game. Now, this is a term from Netcode for entities. It's basically what tells the Netcode system to start synchronizing some constant data. Before the connection is marked as in-game, the only thing we can send are just RPCs, and after we do set it up as in-game, then we can synchronize all data. We can quickly verify that we're not actually sending some constant data if we go on the entities hierarchy, and let's look for a component. for the one that has the network connection. So that's the one that also has the network ID. Let's search for this one. See up here it is, and if we inspect it and we look over here, yep, look at that, look at the snapshots, all 0, none of them moving, none of them changing. So we can see we don't have constant data being sent or received. So let's set up that in-game connection, and the way we do it is actually quite simple. So basically, when the client connects, the client is going to mark that connection to the server as in-game, then the client is going to send an RPC to the server to request for it to become in-game as well. The server receives that RPC and also marks that connection to the client as also in-game. So just a simple 3-step process. Let's build that. And first of all, let's actually clean up our previous testing systems. We're not going to need these two systems. We just made this just for testing, just to see how the RPCs work. So let's go ahead, we can delete all 3 of these. Yep, there it is. So now in our systems folder, let's create a brand new entities iSystem called the Go In-Game Client System. And for this one, let's make it run on the client. So as always, a world system filter run on the client simulation, and world system filter the thin client simulation, so run on both these, okay. And over here on the on update, let's do a system API.query. And what we want to look for is, first of all, we want to look for a network ID, this one inside unity.netcode. Like I said, this is the component that defines a connection. In this case, on the client system, when this component exists, that means we are connected to the server. So let's look for just this one, this is the only one that we need. But then let's also add with none, and with none of the network stream in-game. Yep, this one. So basically, we just want to run this when we have a connection and it's not yet marked as in-game. After it's marked as in-game, then we don't want to run this code. Okay, so yep, just like this. We're going to need to attach this network stream in-game to the entity, so let's also add with entity access like this, and let's put the whole thing inside a for each. So for each, we've got the refro for our network ID. Network ID. Then we have the entity in our query. Just like this. Okay, great. So now here we want to add this component, network stream in-game. So let's make an entity command buffer in order to run that. So a new entity command buffer, allocator.temp. Let's create that one. And then over here, let's run it. So playback state.entity manager. Okay, we have that one. And over here, the entity command buffer, we can call add component. Let's add a network stream in-game. Let's add this built-in component onto this entity over here. So yep, this is how the client marks its own connection to the server as being in-game. Then over here, let's do a debug log using the Unity engine debug. So debug.log, let's print a message saying connected, and let's just print out this entity just so we can see the connection entity. And let's also print out, let's go inside the network ID, and let's grab the value so we can see the value of this connection. Okay, so yep, so just like this, the client will be correctly set up as in-game. By the way, let's also make this proper, meaning let's make this system only run exactly when it should run. Let's make it run only when this query matches something. So up here we can make an entity query builder, create a new entity query builder. So we can do this, create a new query builder with an allocation, searching for with all. So let's look for a network ID component and also a with none in order to make sure it doesn't yet have the network stream in-game component. So we have that one, and then let's do state, let's require for update, and go in this state, get an entity query, and pass in our entity query builder. So we do that, then entity query builder, let's just dispose of it. Okay, so yep, so this is just making things a little bit more clean. Just make sure this update, this entire system, this one is not going to run unless we have this actually happen. So it's only going to run when we have a client connect to the server, and it's still waiting for the in-game connection. Okay, so that's great, this is our system. Pretty simple, like I said, we just connect, we wait for a connection. When it happens, we just add this component and that's it. So this handles over here the first step. The client connects and marks the connection to the server as in-game. Now the next thing we need is this one over here. The client sends a request RPC to the server. So let's first build that RPC over here and let's create a new model behavior, just an empty C# script called the Go In-Game Request RPC. And over here for this one, first one, it's a struct, and then it implements IRPC command, and pretty much just like this, pretty much just an empty one. We don't need any extra data. So we have this one, and then over here on the Go In-Game client system, on this one, let's go down, so we connect, we mark it as in-game, and now we send the RPC to the server. So let's go on the entity command buffer, let's create a brand new empty entity. Find this as the RPC entity. Okay, we have this one. Then on the entity command buffer, let's add a component and let's add just our simple RPC. So the Go In-Game Request RPC. Let's add this one onto the RPC entity. And then in order to send the RPC, let's also do the entity command buffer, add a component of type the send RPC command request on this RPC entity. Okay, yep, just like this. So we already handled everything on the client, so mark the connection as in-game and send the RPC. Now that's left just this one, just the server receiving the RPC and marking the connection to the client as in-game. Before we do that, we can actually verify that this is working, so let's go ahead and play. And then over here on the entities hierarchy, let's go on the client world, and on the client world, look for a network ID, so here it is. And if we look inside it, yep, here we can see it does have the tag network stream in-game. Alright, awesome, so here everything is working. We still don't have any constant data because, once again, we still have to handle it on the server, so let's do that. Let's make another system for that, so inside the systems, make a new entities iSystem. For the Go in-game server system, this one, first of all, mark it as a server system, so world system as a server simulation, okay. Then over here, let's do very similar to what we did on the other side, except instead of listening for a connection, we'll listen for that RPC. So system API, let's do a query. In this case, since we didn't add any data on the Go in-game request RPC, for that we don't even need it over here as a ref.ro, we can just add it as a with all. But we do need the data that we have on the receive command request. So let's add that one, the receive RPC command request. We need this one so we know which connection to attach the in-game component. So let's grab this one and then do with all. And now here we do look for our Go in-game request RPC. So just like this, and we need the entity in order to figure out which one to attach it to, like this. Okay, so let's do a for each on this. So you've got the ref.ro of our receive RPC command request. So this one, then we have the entity in our query, and our query just like this. Okay, so here we are reading the RPC. Now let's add the network stream in-game to the connection entity. Now this is important, it has to be on the connection entity. So we don't want to add it over here to this entity. This is the RPC entity. Instead, we want the connection entity, which is actually inside this component. So first, let's make an entity command buffer, construct a brand new one, as usual, just a simple temp. Then at the end, we call playback with state.enttyManager. Okay, then over here, on the entity command buffer, let's add a component. Let's add a network stream in-game. And the entity that we added to is over here, the receive RPC command request. Let's go inside, read the value. And inside, yep, here we have the source connection, which contains the entity. So this again is going to be that entity that has that network ID component. So it's on this one, we add the network stream in-game like this, and everything should be working. So over here, we can do a debug.log just to see. So client connected to server. So we do that, and then of course we have to consume our RPC, so let's destroy our entity for the RPC entity. Okay, yep, just like this, super simple. Receive the RPC, add that one, and destroy it. That's it. Keep things clean. Let's do the same thing over here on the onCreate. So let's create a new entity query builder. Let's create a brand new one with allocator.temp. So with all, and let's look for our Go in-game request RPC. Yep, with that one. And also with all the receive RPC command request. So that's our query builder. Then state require for update. Let's require for update. Let's go in the state, get the entity query, and pass in our entity query builder. And finally, entity query builder, and let's dispose of it. Okay, that's it. So with this, we have implemented all three steps. The client marks it as in-game, the client sends the RPC, and the server also marks it as in-game. So let's go ahead and test. Also, by the way, just one quick tip here. One tip that relates to either multiplayer game development or really just any kind of development when using dots and burst. If you want faster iteration while making your game, then you should disable burst compile. For that, really just go here, go under jobs, burst, and disable this one. So make sure compilation is not enabled. Now burst is absolutely really awesome. It makes your code insanely fast, but it also takes quite a while to compile. So while building your game, in order to get a faster iteration speed, for that go ahead and disable burst. But then when making the final build, go ahead and make sure to enable it. Okay, so great, so like this, let's test. Okay, here we are, and right away we can see that it did work. So we can see two clients connect to the server. We can see this client connect to the server with an ID of 1, and this client connect to the server with an ID of 2. Then if we look on the server world, let's just swap it just to update. There you go, we've got two network connections, and if we select either of those, yep, here we can see both of them are marked as network stream in-game. And also if we look over here on network connections, if we look inside this component, yep, we can see it is constantly receiving ticks, so constantly receiving and sending and so on. So we can see, yep, both these connections are indeed constantly sending some constant data. All right, awesome. So here we have a connection fully established. We can send and receive RPCs, and snapshot data is also being sent and received. Now, in order to verify it even more, we can actually use yet another tool. So let's go up here into Window, then go into Multiplayer, and over here we can open up the Network Debugger. And if this one opens up a window in your browser, and if the game is playing and we click on this window, and now if we had some data synchronized, this would update and show various graphs. So you can use this to debug all kinds of things in your multiplayer game. Okay, so yep, here we have a basic connection up and running. We'll learn about the automatic bootstrapper, we'll learn how to send RPCs, and we also learn how to set up the connection as in-game. Now that we have this connection established, we can finally start to build our game. So let's start by building our grid in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to set up our grid so we can click on the various grid positions. Okay, so let's build a grid to play our game. First, let's just build the grid visual. And of course, one very important thing, this game that we're making is a 2D game. However, Unity Dots doesn't currently support 2D sprites, at least not natively. If I go here on the game subscene, I create a new empty game object, and I attach a sprite render component to it. And we'll look down here on the baking preview. We can see, yep, this is going to be a companion game object. So this is not a native Dots entity. Dots does not yet support sprite renders at the time of this recording. So instead of using sprite renders, instead of that, we're just going to do the alternative of simply creating a quad mesh. So over here on the game subscene, create a new game object, go under 3D, and just create a quad object. So yep, this functionally is exactly the same thing. So we can see over here, it's just a flat mesh. So in essence, it really ends up the same thing, except this one by being just a normal mesh filter and mesh render, because that over here we can see this is a native entity. So yep, this is what we're going to use. And on the project files over here, we already imported a bunch of assets, including a bunch of materials for some nice visuals. So for example, on this one, let's drag the background material. And there you go, there's the background material. So we have essentially the same thing as a sprite render. It's a flat visual, but by doing it this way, we are doing it natively with dots. So yep, this is exactly what we're going to do. Mesh filter, mesh renderer, and by the way, let's just get rid of the mesh collider. We don't need that. So yep, very simple. Okay, so this, for example, is going to be our background. Let's rename it, and let's get rid of these other testing objects. Okay, great. Now, since our game is 2D, let's also go on the main camera, and instead of perspective, let's make it an orthographic camera. Let's put it with a size of 5, okay. And over here for the X and Y, put on 0. And for the Z, yep, let's leave it on -10. Okay, so this is the camera, and for the background, let's just stretch it out. So on the size, let's put an X of 18, Y of 10, just like this. And also yet another thing, since we are not working with sprite renders, since we're now working in 2D, because that, we don't have access to the usual sorting layers and sorting orders, at least not easily. So for sorting, since we are using 3D objects, we're really just going to use the Z. So we're going to move objects either closer or further away from the camera in order to make them in front or behind. So in this case, for the background, we want it to be behind everything. So let's put it on a Z of 0.1. Okay, great. So this is our background. Now let's make our lines. So once again, let's right click and we're going to create a new quad game object. Let's name this our line. Then let's drag the inline material. Yep, there's the line. And also over here, let's get rid of the collider. Okay, so now for the shape, let's put it with a scale of 10 and 0.6. Then for the position, let's put it 1.5 on the Y. Let's duplicate this one. Let's put this one down here on -1.5 on the Y. Let's duplicate again. Then on this one, let's rotate 90 degrees on the Z. Let's put it on a Y of 0 and on an X of -1.5. Duplicate it again, and this one on +1.5. Yep, there it is. So here we have our simple grid visual. So now the next thing is we want to be able to click on any of these positions. And for that, just like with any programming problem, we have many possible solutions. For example, we could just use math to check the exact position of the mouse. We could just use that to figure out where exactly are we clicking. Or alternatively, we could actually just build this whole thing inside the canvas. That would also work. Or we can just use some normal colliders and use a raycast to click on them. So let's go with that approach. First, let's create the object that is going to occupy each of our grid positions. So let's create a brand new one. Let's make it also a quad. So 3D object, a quad. Yep, there it is. Let's scale it to occupy, so that's 2.6 on the X and Y. Yep, that's the perfect scale. Now, importantly, since we're going to be using raycast, we're going to be using physics, but we don't want to use the mesh collider, so let's remove this. Instead, let's add a box collider. And also importantly, it's this one. It's the 3D one, not the 2D one, so let's add this one. Let's add it, and by default, it should already have the correct shape. So just 1, 1 on the X, and on the Z, let's put it 0.1, just so we can see. Yep, there you go, that's the actual perfect shape. Okay, that's great. This is going to be our grid position. And let's make this into a prefab so we can then modify it before we duplicate it. So on the assets, create a new folder for our prefabs and just drag the position onto it. Okay, so now let's just position all of our prefabs on all the positions. So let's duplicate this one and put this one on an X of 3.1. Yep, there we go on that side. Then another one on an X of -3.1. Let's grab all three, duplicate them, put them on a Y of 3.1. Duplicate again and put these on a Y of -3.1. Like this. Now let's give them proper names just so it's a little bit easier. So this one is on the middle. So if this one is going to be the 0, so 0, 1, 2. So this one over here is on 0, 1 and 0, 1. So this one is on grid position 1, 1. Then this one over here is up top. So this one is on 1, 2. This one is on the bottom, so this one is 1, 0. Then this one on the right there, so this one is 2 on the X and Y on the Y. Then this one is on 2, 2. This one over here is on 2, 0. Then this one is on 0, 1. This one is on 0, 2. And finally, this one is on 0, 0. Okay, yep, so we have all of our grid positions, all of them perfectly positioned. Also, by the way, we don't need the visual. We're actually going to hide this in a little bit, but for now, leave this enabled so we can see one thing in a little bit. The visual is really just used for debugging right now. After we have everything set up, we can get rid of the visual. Really, all that matters is just that the colliders are positioned correctly. So yep, like this, so far so good. Now let's make the script that is going to click on our grid positions. So let's go in our scripts folder, inside the systems, create a new entities iSystem, call the grid position click client system. This one is only going to run on the client. So yep, over here, let's begin with that. So on the world system filter, run this just on the client and the thin client simulation. Okay, yep, so just like this. Now here, let's test for a mouse button click. So if input get mouse button down on the left mouse button. By the way, here I'm using the legacy input manager, but of course you could use the new input system. That would work perfectly fine, especially because this game is so limited in terms of input. I'm going to be using this one just for simplicity, but at the end of the game, you can definitely easily refactor this to work with new input system. So up here we are testing for the left mouse button down. So when we do that, let's do a simple physics query. So for that, we're going to need to access the physics world singleton. So system API, get the singleton of the physics world singleton. So yep, this one over here, this returns the physics world singleton like this. Again, I covered all this in detail in my dots course. So here I'm assuming you know pretty much everything about dots except for the netcode part. So to do a physics query, first we grab the singleton. Then from that one, we can grab the collision world. So that is going to be the collision world for our collision world. Okay, we have this. And inside this one, we can call cast ray in order to do a raycast. This one takes a raycast input, so let's build that one. This one requires a start and a filter. So for the start, this is the start position for our raycast. For that one, it's going to be the mouse world position. So let's calculate that one. We can go inside the camera, grab the main camera, and then call screen to world point and pass in the input.mouse position. So yep, this is going to receive a vector 3 for our mouse world position. Okay, we have this, so this is going to be our start. And by the way, we can actually do a log just to verify what this is saying. So let's print out our mouse world position. So let's test this. So here we are, and if I click right down the center, yep, there we go, that is pretty close to 0. And if I click up top, yep, the Y is pretty close to 5. So yep, here we have our nice world mouse position. Also one thing, note how the Z over there is -10. That is because our camera is positioned at -10 on the Z. So over here for our raycast, the mouse world position, yep, that is going to be our start. Then for the end, that is going to be, let's put it basically the mouse world position, and then just add a new float 3, just add an offset on the Z. Now we can add any amount as long as it's more than 10, so let's put it at 100. And then we have the collision filter. And for this one, for example, if we wanted, we could make all the colliders in their own layer and only hit that layer. Technically that would be a little bit more performant, but since we're really not going to have many more colliders, or really any other, because that, let's really just use defaults. So let's use collision filter.default, and this will work perfectly fine. Okay, so yep, so this is our raycast, and then after the raycast, let's grab the out for the raycast hit for the raycast hit. Let's just make sure that over here we are using Unity physics.raycast hit, not the Unity engine one, that's a different one. Okay, so we test, and if the raycast hits something, if so, then that's great. Let's just do a debug.log and print out the entity that we hit. So raycast hit, let's print out the entity. Okay, so yep, just like this, let's test. So here we are, and if I go in the middle and I click, and nope, there you go, it is not working. Let's just add a log up here, just make sure the click is working. So a click log over there, and I go and I click, and if there you go, it is correctly testing for the input, but the raycast is not hitting anything. Now this is actually a really annoying issue. This is something that took me quite a while to figure out. Why is this not working? All the code that we wrote here, all of this code, all of this should be working. This code is 100% correct. And in fact, if we didn't have the Netcode for Entities package installed in this project, if not, then this exact same code, this would be working fine. But it turns out that Netcode for Entities works in a slightly strange way. Just by installing that package, just by doing that, all of a sudden physics stops working. Or rather, it starts working in a very different way. If you just install the package, then physics will not work exactly the same as if the package is not installed, even if you don't even have any connection set up. I tried uninstalling the package and this code worked perfectly fine. It does do a raycast, it does hit the objects, but since the package is installed, this does not work like this. It seems that when we install the package, in the backend, Unity somehow changes how it handles physics. I think maybe it creates a separate physics world or something like that, maybe a separate world that only has the spawn objects that exist on the network. I think that is why this raycast might not be hitting anything. So yep, the whole thing is very strange. It took me a very long time to figure out why this code wasn't working. The answer is it's because the package, when that one is installed, we need to do a bunch more things to make it work. So the first step is to set up a connection and make it in-game, like we already did. And secondly, we need to mark all of these objects as being ghosts. So this requires us to learn the concept of what is a ghost in Netcode for entities. Ghosts are basically what they call a networked object. For example, if this game were a game where you control some kind of player character, if so, then the player object would be a ghost. By doing so, it would automatically synchronize the entity spawning, destroying, and all the local transform. The player object would be a ghost, and by being set as a ghost, it would automatically synchronize that data, so all the other clients, they would see that object would be spawned, it would be destroyed, and the local transform would be synchronized. Now, in this particular game, we don't really have a player object that we control, but we do want to synchronize these grid positions. They should exist on both the server and on the clients. So for that, let's make this grid position into a ghost. Let's go inside the prefab so we modify all of them. And over here, let's add a component and search for ghost, and yep, the ghost authoring component. So if there it is, we can see it added. Here we see it has a bunch of settings, but we can't just leave all of these on defaults. So let's go ahead, let's go back, save the prefab, and yep, there it is. Over there on the scene view, we can see these icons, the ghost icons. So this means this object is a ghost. We see the same thing over here on the hierarchy. And also note one very important thing. When we add this component, all the visuals suddenly became invisible. So this is intentional, this is what happens. This is why I told you to leave the visuals on, just so you can see this happening. When we make something a ghost, for some reason, it doesn't spawn a visual by default, only when the connection is actually established. Now, if we play the game, if there you go, as soon as the connection is established, we do see the ghosts, they do spawn, so that's great. By the way, if you don't see them, then make sure you have your in-game logic set up correctly. The connection needs to be marked as in-game in order for these to spawn automatically. If it is not in-game, it will not spawn. But here we already handled that, the connection is already marked as in-game, so we do see them, that works. But if we click, and yep, there you go, look at that, it still does not work. Like I said, it took me quite a while to figure out all of these tiny edge cases. And in this case, I believe this one is actually a Unity bug. At least there is a post on the forums that talks about that. Basically it has to do if there aren't any predicted ghosts and something doesn't happen, so it's a little bit strange. But the solution is to add a nice config authoring component. So for here in the game, for the final thing that we need, inside our game subscene, let's create a new empty game object. Name this the netcode physics config. And let's add that same component, so netcode physics config, this one. And over here on this option for the physics group run mode, which by the way, if you don't see this option, that's because you're on Netcode for Entities version 1.3 and not 1.4. That is why I recommend you start from the exact same project files as me, in order to make sure you get the exact same version so everything looks exactly the same. So over here on this drop-down menu, we have these options, and here we need to change to this one, lag compensation enabled or any physics entities. If we do this, and now we test, and now we go ahead and click, and if there you go, now all of a sudden everything does work, so we can see we are indeed clicking on our entities. We can do a raycast, and raycast now finally actually hits something. Alright, awesome. So yep, after doing all of that, we finally got it working. We need to make the grid position, make that prefab into a ghost. Then in order for the ghost to spawn, we need to mark the connection as in-game. And finally, we need this one over here, the netcode physics config. We need this one to be set to this special place. If we do all those things, then yep, now all of a sudden everything does work. We can click and we can identify all the entities that we click. Like I said, it took me quite a while to figure out why the clicks weren't working. I was going crazy for quite some time. So I'm really hoping that this helps you avoid the same frustration that I went through. Okay, so this is working, so we can continue. Now we can go inside our grid position prefab, and now we can hide the visual. We no longer need it, so let's hide it, go back like this. So if we test again, okay, here it is, we've got just invisible colliders. So if we click outside of it, then nothing happens, makes sense. But if we click inside, if there you go, that one is hitting various entities. Okay, great. So we can now click on our grid positions, but we don't know exactly where we clicked. So let's sort the X and Y coordinates for our grid positions. We're going to make a component, so before that, on the scripts folder, let's create a new folder for our components. Yep, like this, and now inside, let's create a new model behavior script for the grid position authoring component. Okay, so here let's make a standard authoring component and the dots component. So for dots component, it's a struct called grid position, implements I component data, just like this. Then for that inside, we just have an int for an X and an int for the Y, like this. Then on the authoring component, let's make the usual baker. So baker, implement baker of grid position authoring. Then we implement this function. And this one for the entity, we get the entity with transform.dynamic and add component on this entity, a new grid position. Then for assigning those, let's go up here on the authoring component, also make a public int X and Y. And then we assign the X equals the authoring.X and the Y equals the authoring.Y. So that's it, just a very standard authoring component and a very standard normal dots component alongside the baker. Again, I covered all about authoring components, all of this in my free dots course. This is all just simple basic dot stuff. Okay, so this is great, let's go ahead and save. Now here in the editor, let's select our grid position prefab and let's attach our grid position authoring component. So there it is, now they all have it. Now let's just go ahead and assign those values over here. So this one is the 1, 1, then this one is on 1, 2, this one is on 1, 0, this one is on 2, 1, then this one over here is on 2, 2, this one is on 2, 0, then this one on 0, 1, this one on 0, 2, and finally this one on 0, 0. Okay, we have all the values. And over here on our click line system, on this one we are raycasting hit, we are hitting the entity. So then we can just use the system API, check has component of type grid position on this raycast hit.entity. So if we hit something that has that component, if so, let's grab that component. So system API, get the component grid position of the raycast hit.entity. So we're going to grab the grid position for that one. And then let's just do a log, just make sure it worked. So clicked and then clicked, let's pass in grid position.x plus grid position.y. Okay, so yep, that's it. Very simple. Let's test. Okay, so here we are. And if we click outside, yep, nothing. Now if I click, let's say over here, this one should print 1, 1, click. And if there you go, 1, 1, this one over here, 0, 0. Yep, there it is. This one is 2, 2. And yep, there it is. All of them work perfectly. All right, awesome. So yep, here we now have some clickable grid positions and the ability to know exactly where we clicked. In building this, we also learned about netcode ghosts and the quirks with working with physics in networking. So now that this is working, let's begin handling our logic. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a game server system that will handle the server logic, and we're also going to spawn some visual ghosts, which will then spawn across all the connected clients. Alright, so right now we have our grid positions, and we have the ability to be able to click on them. So it works on either client, all of those work, so we can see we are getting the correct clicks. But now this is a client system, so this is all running locally. Now we need to tell the server that we clicked on a certain grid position. And the way we're going to do that is through a simple RPC. So let's begin making that. On our RPCs folder, create a new model behavior script called the clicked on grid position RPC. This one, an RPC, so as usual, let's make it a struct, then implement IRPC command, open and close. For the data we want to pass in, let's just pass in the x and y, so int x and int for the y. Okay, like this. So now over here on our grid position click client system, on this one, so here we are clicking, and over here let's send an RPC to the server to tell it that we clicked on this position. So as usual, RPCs, very simple. Let's just create an entity. So state, let's go to the entity manager, create a new entity, name this the RPC entity. And actually over here when we create, we can already create it with a certain archetype. So let's create it already with our things. So let's start with the type of our clicked on grid position RPC, and also the type of. In order to send it, let's use the send RPC command request like this. Okay, yep, so then state entity manager, let's just set the component data. On the RPC entity, let's set a new clicked on grid position RPC. And for this, for the X, let's go in the grid position. Let's grab the X, then same thing, grab the Y. Okay, yep, very simple. So here we are creating and sending the RPC. Now let's make a server system that will listen to it. So over here in our systems, let's create a brand new entities iSystem. Call this the GameServerSystem. And over here, let's make this one run on the server. So world system filter, run just on the server simulation. Okay. Now here, let's listen to that RPC and consume it. So do a system API, doing a query. Let's grab that one. So refro for our clicked on grid position RPC. And let's also grab the received RPC one. So another refro for the received RPC command request, just in case we need to do something with what user sent this RPC. So we have these two, and then so we can destroy the RPC, let's add with entity access. Okay, so for each refro on the clicked on grid position, then a refro for the receive RPC command request, and finally entity. Okay, yep, this is our query. So over here, let's handle that RPC. So handle the clicked on grid position RPC. Over here, the server does know that we clicked on something. Let's just do a log just to see what the server sees. So let's say the server, and we clicked on something. So let's print out, go inside that one, grab the value, grab the X, then another one, go inside it, grab the value, and grab the Y. And let's also say who sent this. So let's do another print. Let's go inside the receive RPC command request, grab the value, and grab the source connection. Okay, yep, and as usual, after we consume an RPC, we need to actually destroy it. So let's create an entity command buffer a brand new one with allocator.temp. Then at the end, nt command buffer, let's call playback on the state.ntManager. And over here, nt command buffer, let's destroy the entity and destroy this entity. Okay, yep, just like this. So super simple. Once again, just reading an RPC. Like this, let's test and see if the server does get notified when we click on either client. Alright, so on this one up top, if I click over here on 00, yep, there it is. So this is the local message, and yep, this is the server message. So it is telling us this client connect on entity 4661, this one clicked on 00. If I click over there, yep, 11, 22, and so on. And over here on this one, if I click, let's say on this one, yep, there it is. This one got the local clicked and then sent the RPC and then received it over there on the server. Alright, awesome. So we are successfully telling the server where the client wants to take an action on the grid position. Now that we have that on the server, we can now spawn a visual. So here in the project files that we imported, again, for the textures and materials, I included a bunch of symbols. So we've got a cross and a circle. This is really all we need to make this game. So let's make a prefab to spawn these. So let's go inside our subscene. Let's create an empty game object. Call it just the cross. Then inside it, let's make it a brand new 3D quad. And now on the quad, let's assign our material. So let's go with the cross material. Yep, there it is. Let's just scale it. So X and Y of 2.6. Then also this is just a visual. So over here, let's make sure to get rid of the mesh collider. Okay, so yep, just like this. And now in order for this one to be spawned across the network, for that it needs to be a ghost, like we already saw for the grid positions. So let's go inside our cross, and over here, let's add the ghost authoring component. Again, make sure you add it on the parent, not the child. So we have this one, and we see a nice error message. Basically, ghosts always have to be prefabs. So let's go ahead, drag it into our prefabs folder to make a prefab, and get rid of it over here on the scene view. Okay, great. So then let's make the circle. So let's just duplicate the cross, name it the circle. Let's go inside of it. And on the quad, let's just use the other one. So the circle material, yep, just like that. Okay, great. So here we have both of our prefabs, both of them marked as ghosts. Now all we need to do is really just spawn them. Now, when it comes to spawning, in dots, it's always slightly tricky to get references for what objects we want to spawn. Usually in normal object-oriented code, I would just have some kind of mono behavior attached to some kind of object, and then that mono behavior would have direct references to whatever I want to spawn. But in dots, systems that would spawn objects, those systems don't really have any place over here on the subscene for dragging any kind of reference. So in dots, the way that I like to do is just have a component that holds pretty much all the references that I need. That's how I did it in my dots course. I quite like that pattern, so over here let's do the exact same thing. First we need an authoring component to hold those references. So on the components, let's create a brand new mono behavior script. Call it entities references authoring. So yep, this one. And now here, let's make the usual simple stuff. So a struct for entities references. Make this an I component data. Then up here, let's make the usual Baker class. So Baker entities references authoring. Let's bake this one, implement it. Let's grab the entity, get the entity with dynamic, and add a component on this entity, a new entities references. Okay, great. So like this. Now let's just add fields for the things that we want to spawn. So over here on the dots component, let's add a field of type entity. And this one is going to be the cross prefab entity. And then another one for the circle prefab entity. So you have these two, and now up here on the authoring component, instead of entities, let's add a field of type GameObject for the cross prefab GameObject. Another one for the circle prefab GameObject. So we have these, and then when we add the component, for example on the cross, we use getEntity and pass in the authoring dot cross prefab GameObject and pass in with dynamic. So that's it, and same thing for the circle, like that and like that. Alright, yep, that should do it. So the authoring component has GameObjects, and then the dots component, that one has entities references. So here in the editor, let's wait for it to compile and then create this object. On the subscene, let's create an empty game object, call it entities references. Then over here, let's attach that component, so entities references, and let's drag those. So the circle prefab on there and the cross prefab on there. Okay, so we have our references. Now over here on the GameServerSystem, for grabbing those, let's just grab, since we just have one, we can easily grab the singleton. So system API, get the singleton of type entities references. So grab this one, so entities references for this. So grab this one. And by the way, this one is actually going to throw an error if the singleton does not yet exist. So let's make sure over here to also write the on create ref system state for our state. Let's add the burst compile. And on this on create, let's do state require for update. Make sure it doesn't update until we do have an entities references. Okay, so that's great. Now over here, when we have our RPC, okay, we handle the RPC and so on, then let's just spawn that object. So we're going to just go nt command buffer, call instantiate, go inside our entities references, and just grab one of these. Now, right now, we still don't yet have the concept of what exactly is a player type, meaning crosses or circles. So for now, let's just always spawn just the cross prefab. So just like this. So entity for the player object entity. So we spawn that one. And then let's also position it correctly. So go in the entity command buffer, let's set the component data. On this player object entity, let's go local transform, which exists inside unity.transforms. So let's go inside this one, use the from position, and now pass in the position. But of course, we don't want to pass in the grid position. Instead, we want the global world position. So let's make a nice helper function to do that. And the way that we do is actually quite simple. Over here, the way we define things, on right down the middle, we have 0, 0. And then the position on each of them is 3.1. So for example, if I create a new empty subscene, just so we can see exactly where we are. So over there, we can see, yep, so that's position 0, 0. Then if we go 1 to the right, that is 3.1. If we go 1 above, that is also 3.1. So essentially, since we start 0, 0 on the middle, we go left and we go down. So we start off on minus 3.1 on either one. And then we basically just add the grid position multiplied by 3.1. So if we are on position 1, 0, start from minus 3.1, minus 3.1, then add 3.1 on the x, and we end up on 0 minus 3.1. So yep, that's it, pretty simple. Over here, let's define a constant for our grid size. So private const float, let's name it our grid size, and that's 3.1f, okay? And then let's make that helper function. So make a private, return a float 3 for our world position, call it get world position, pass in an int x and an int for the y. Then on these, let's just return a new float 3. And like I said, first start from the negative, so minus grid size, so start from there, plus the x multiplied by the grid size, and same thing for the y, so minus grid size, plus the y multiplied by grid size. Then for the z, doesn't really matter, let's put it on 0. So yep, over here we can pass in the get the world position, and for the world position, let's grab that one, so let's find here a float 3 for the world position, get the world position, go on the clicked on position RPC, and grab the x, and on that one, let's also grab the y. So we do that, and then over here, use the world position like that. All right, so this should be spawning our cross prefab, and should be positioning it correctly. And since we already made it a ghost, it should also be spawning on all the clients. So let's save it and let's test. Okay, so here we are, and on this window on the host, let's go ahead and click. And if there it is, there's our spawn object. So it spawned and also spawned on all the connected clients. So it spawned and went to the right position. Then if we also try to take an action over here on this client, if we click, and if there you go, same thing, this one sends an RPC, this one spawns, and the spawn is automatically synchronized across all of them. All right, awesome. So yep, this is how easy it is to spawn objects on all the clients. Really just need to make them ghosts and spawn them, and that's it. It automatically gets synchronized across all the clients, and it synchronizes all the transform data. Now, since we're talking about spawning ghosts, we should also cover one very important thing about almost any multiplayer game, how they're usually server authoritative, meaning that there's an ultimate source of truth, and that one is usually the server. So only the server is allowed to spawn objects, only the server is allowed to modify certain data. If we try to spawn a ghost on the client, let's see what happens. So let's just copy our instantiate code, and let's go, for example, over here on the grid position. So this is a client system. So over here, let's try spawning it directly. Let's just pass in the singleton reference for this one. Instead of entity command buffer, state.entity-manager, let's instantiate it like this. Okay, so yep, so this code is running just on the client, not the server. So let's see what happens if we run this. Okay, so here we are, and if down here on the client, if I go ahead and click, if there you go, look at that, look at how it actually spawned a visual, but then disappeared. So as I click, it is spawning the actual one that is being sent for the RPC, so that one makes sense. But it's also spawning one on 0, 0, that's the one that we are just spawning, and note how it got destroyed right away. So that's what happens if you try to spawn a ghost on a client. If so, basically it will spawn the object and then get destroyed pretty much on the next server tick. That's the same thing over here on the client, as well as over here on this one that is working as a host. This one has both a client and a server. But over here, if we click, yep, the same thing also happens. That is because, once again, Dots has a nice separation between the server and the client world, and that system is running over here on the client world, so it's literally running exactly the same thing as down here. So if we click, it spawns and it happens the exact same thing. So if you try to spawn a ghost on a client system, if so, then it does spawn, so it doesn't throw an error, but then the whole thing gets destroyed because, once again, the server is the only thing that matters. So always remember that. If you're making a multiplayer game and your ghosts are not spawning correctly, if so, make sure you're spawning them on the server and not the client. So over here, let's just clean up our code, get rid of this, save it. So now here, if the server takes an action, yep, it works. If the client takes an action, yep, it also works. All right, awesome. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to define some player types and use the client ID to assign them. Okay, so right now this is working. We can click to place an object anywhere on the grid. I can click on this one or click on the client. The whole thing works. But right now, both players are playing as crosses. In reality, we want one to play crosses and one to play circles. Now, the simplest way to handle that is to make the server the cross player and the client the circles player. So to do that, first let's define those two types. And let's actually do it properly. So for defining what is a cross and what is a circle, for that, let's not use something like a string. That's terrible. Strings should really only ever be used for text. They should never be used to identify types. So in order to do it properly, let's use an enum. It also has the benefit that enums are easy to synchronize across the network, whereas strings are not. So yep, over here on the project, let's go on our scripts folder. Let's create a brand new monobehavior script and call it just the player type. Okay, so now here, this one is not a class. It is an enum and does not extend anything. So just like this. Then for the values on our enum, for the first value, let's start with none. Usually the first value of an enum should always be some sort of invalid value. That way enums are invalid by default. You need to give them a proper value for them to be valid. So we have that one, then let's have cross and circle. Okay, yep, just like this. And now for storing the local player type, for that, let's make a component to store some general client data. So over here, let's make a new component, so a new monobehavior. Call it the game client data authoring. So yep, here let's do the usual thing, just a simple struct for the game client data. Let's implement iComponent data. Do it like this. Then over here, the usual class for our baker of game client data authoring. Then let's implement this abstract class. So entity, get the entity of type dynamic, add component on this entity, a new game client data. Okay. So now for the data that we want to store, like I said, we just want to store the local player type. So here, just a player type for the local player type. Yep, like this. And up here, we actually don't need to expose any baking data. Basically, this field over here, this one will be assigned only through code. So if we have this, pretty simple, let's save. Then let's just make sure that we have an entity with this component. So let's go inside our subscene. Let's create a brand new empty game object for the game client data. And just attach that one just like that. Okay, so now for assigning the local player type, for that, over here on the GameOverUI client system, on this one we already see, yep, we are connecting, and over here we have the network ID value. So we can assign that based on the ID of this connection. We can see the logs to see what this says. So yep, over here, this one on the host, this one has an ID of 1, and over here the client has an ID of 2. So yep, we can just use this. Although I should say that technically this can actually be inverted. Sometimes in my testing, I've seen the host end up with index 2, and this one end up with index 1. I think it has to do with the fact that the host client world, that one doesn't actually spawn instantly. So the server world might spawn, then this one spawns, and then the other one spawns, so that might lead it to being flipped. But either way, it doesn't really matter. It's not really a requirement to make the host play the crosses, they just have to be playing different types. So yep, over here we can use that. So let's check if the value equals 1. If so, let's make this one play the crosses. So for that, let's go in the system API, get the singleton, and let's use get singleton RW so we can write to it, of the game client data. So let's grab that one. So game client data like this. And actually this is a ref RW, so we can write to it. Then let's go inside the value RW and set the local player type. And for this one is going to play the crosses. Else, if it is not 1, if it is 2 or anything else, if so, let's play these circles. Okay, yep, just like this. Let's do a log just to see that everything is working correctly. So assigned, and then let's say what we assigned to this one. So just grab the local player type like that. Okay, so that's great. So that means we now have the local player type. So now we can go over here on the GameServerSystem. So on this one, when we are receiving the RPC, over here we are instantiating, and we're instantiating this one. So it's this that needs to change based on what player type we're using. And over here, you might think, okay, let's just do a switch on the player type stored in the component. So over here, system API, let's get the singleton of type game client data. Let's grab that one. And over here, let's just do a debug.log, just see this one. Go inside that one and grab the local player type. So yep, let's see this and see if this one is saying cross and circle depending on client and host. So right away for the assign, it did work. And actually it happened, the one thing that I said sometimes happens. So this one over here, the client, this one got ID of 1. So this one's playing crosses and this one's playing circles. Like I said, either way, it doesn't matter. So now if we click, and if there you go, look at the log, that one said none. It didn't say cross or circle, it just said none. And over here, if I click on this one, yep, same thing, also just says none. So yep, this is not working. The issue here is all about client versus server data. The local player type that we are assigning on the game client data, we are only assigning it here on the GameOverUI client system, and this one only runs on the client. So the client is the only one that actually has this assigned. Again, when working in multiplayer, always remember what that is on the server and what that is on the client. Remember how the dot swirls, those are completely separate. So if on the server, if we try to get this one, the game client data, that is really just going to get basically an empty component. It is not going to get the one that the client actually assigned. Now, to solve this, it's actually quite simple. We really just need to pass in the player type that we want to use, and we can pass it in over here on the RPC. So let's go to the grid position client click system. So this one is running on the client. And over here, let's go ahead and grab that one. So we've got the grid position. Let's also get system API, get the singleton of type game client data. So let's grab this one, the game client data like this. So you grab this one, and then let's just modify the RPC. So let's go inside of this one, and let's make a public of type player type for the player type. Then on this one, just set the player type equals the game client data and grab the player type. So yep, since this one is running on the client, that means this one is going to be correct. And over here on the GameServerSystem, when we are spawning, let's not access the game client data. Instead, let's use the one inside of this. So let's just do a switch on that one. Click on grid position RPC, go inside the value and grab the player type. And let's do default and case cross. If so, let's spawn one prefab, and case circle, let's spawn not prefab. So up here, let's just define an entity for the player prefab, and then on the cross, player prefab equals entities references. In this case, let's grab the cross prefab, and on this one, let's grab the circle, and then at the end, we use whatever one we select. So the player prefab like this. So let's rename this so player prefab entity because it's an entity. Okay, so yep, so just like this, let's save everything. Let's wait for it to compile and let's test. Okay, here we are. Down here we have crosses. Up here we have circles. If I click, yep, there you go, there's a circle. If I click, yep, there you go, there's a cross. All right, awesome. So different places now spawn different symbols. So that's great. But one thing, which is how right now the same player can take as many turns as they want. Right now the game has really no concept of what exactly is a turn. So let's add that. It's actually pretty simple. We really just need to keep track of a field on the server of who exactly is the next player and only allow that one to take actions. So this time, since we want to store some data on the server, let's make another component. So on our components, create a new, let's make a mono behavior. This is going to be the game server data authoring. And yep, now here let's do very much the same thing. So we struct game server data. It's an I component data like this. And up here, a class for our baker of game server data authoring. Okay, then let's implement it and the usual thing. So entity, let's get our entity with dynamic, and let's add component on this entity, a new game server data. Okay, yep, just like this. And the data that we want to store on the server is the current playable player type. So let's define a player type for the current playable player type. So only this player type can currently play. And this one is going to be set dynamically, so let's not set it over here. And again, remember, by default, player types are set to none. So if you leave it just like this, no player is going to be able to play. We want to default this to cross in order to start the game. And later on, we're actually going to implement the concept of starting the game. We're going to handle that in a few lectures. When we do, then we're going to set this when that happens. But for now, let's just actually go over here on the game server system, and let's just do a quick check. So over here, let's grab that one. So system API, get the singleton RW of our game server data. Let's grab that one, the game server data. So we grab that one, go inside on the value RW. Let's set the current playable player type, and let's check. So if the game server data, if that one dot current equals none, if so, that means it's invalid. If it's none, let's set it to cross, so the cross player plays like this. Okay, great, so that handles the initialization. Like I said, in a little bit, this is going to be done more properly through some kind of start game logic. But for now, let's put it just like this. Let's put it inside parentheses so that down here we can access the same game server data. So here we are, we have the RPC, and now it's over here that we want to check, can this player actually take this action? Now in this case, we just need to read it. So let's get the game server data, the same thing. And let's check if the game server data, let's read the value for the current playable player type and see if this one is different than the clicked on grid position, the value for the player type that made this action. If it is different, then this player is not the one that is meant to be playing. If so, then let's skip it. So let's just write continue. But if it is this one, if so, then let's let that player take an action, and then let's just basically swap it. So if the game server data, let's read the value of the current one, if that one equals the cross. If so, let's go inside that one for the value for the current one. Let's set it to circle. And if not, then let's set it back into cross. Okay, yep, just like this. So basically over here, check if it's this player's turn. And if not, not this player's turn, skip. And if it is, then swap the current playable player type. Okay, so this is it. Let's save all our files and let's test. Let's just remember to make an entity with our component. So a new empty one for the game server data. Let's attach the game server data like that. Let's also make sure to save it so the changes are propagated to the player 2. And now we can test. Okay, yep, so everything is working. Now if I click, yep, there you go, this one took an action, makes sense. But now only the circle should be able to play. So now if I try to click, and if there you go, does not happen. So it is capturing clicks, but it is correctly ignoring them since the cross player is not the one meant to be playing. And now down here on the circle, if I take an action, if there you go, that one does work. Now this one, try again. Nope, doesn't work. Has to go this one. So it has to go crosses, circles, and so on. And like this, everything works perfectly. All right, awesome. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to handle events in dots. This is very important to keep our code quality high. Okay, so our game is taking shape. We have some logic assigning the local player, and it's different depending on the client or the host. We added that logic over here on the GoInGame client system. So over here on the update, we test for the GoInGame, so we do the whole thing. And over here, we check for the network ID, and depending on that, set it as cross or circle. So yep, technically this does work, but I really don't like this. This class over here, it is named GoInGame client system, but in reality, right now, it's being responsible for the GoInGame system, but also being responsible for assigning the local player type. Anytime you think of what responsibilities a class has, and you use the word and within that, that's always a hint that the class might be doing too many things. So over here, I don't think this is right. The GoInGame client system, this one should only be responsible for setting the in-game connection. It should not be responsible for setting up the local game state. Now, in normal object-oriented programming, in there over here, I would just fire some kind of on-connected event. I would fire this event and then have some other class listen to that event and handle setting up the local player type. Events really are one of my favorite C# features. They allow you to easily write some very high quality, very decoupled code. But events, C# events, those are objects. Therefore, they cannot be used in dots, at least not natively. So this is a little bit tricky. We want to make our code high quality, we want to make things nice and decoupled, but we want to do it inside dots. So what we can do is try to build a dots-based event system. Now, there are actually several ways we can do this. For example, in my dots course, I made it mostly based on just setting booleans on some components, so that's one approach. That's a great option if you already have components, like for example in that course we have components for like shooting. So in that case, it makes sense to just add a boolean in that component to define the event, like onShoot. However here, since we don't really have any components like those, because of that, let's go with a different approach. Let's do a method similar to RPCs. Meaning, let's create some entities and attach components when some event happens, then have other classes look for those components to know when the event happened, and another system responsible for destroying those event entities. So yep, let's do that. First, let's define the event. This is going to be just a similar component, so on the components, make a new monoBehavior. Call it in this case on connected event. And over here, this one is going to be a struct. It is going to implement iComponentData, and pretty much just like this. For the data that we want to store, let's just store a public int for a connection ID. Okay, yep, great. So this is our simple component. This one represents our simple onConnected event. Now over here on the GoInGame client system, on this one, instead of assigning this over here, we can just fire off an event. So for that, let's just go on this entity command buffer, and let's create a brand new entity, and let's do a type of, let's create with our onConnected event. So over here, let's go on the entity command buffer, and let's just create an entity. And then on that entity, so entity for the onConnected event entity, we have this one, then entity command buffer. Let's go inside it. Let's add a component on the onConnected event entity, and let's add the onConnected event. Okay, yep, so just like this one is going to add the event, so it's going to create the entity and add the component onto it. Now we just need to listen to it. For listening to this, let's make a general client system. So on our systems, let's create a new entities iSystem for the game client system. Inside this one, first of all, make it a client system. So world system filter, make it run on the client or the thin client. Okay, so we do this, and then over here on the onUpdate, let's do a simple query. So system API, do a query. Let's look for our component, our event, so the onConnected event. And yep, that's really it. So up here, let's do this query. So for each ref.ro onConnected event, onConnected event, in our query like that. And now, yep, now it's over here that we can basically run this exact same code. So let's copy this, get rid of it from there, and just paste it over here. For the network ID, that one is going to be inside that one. We've got the, let's read the value for the connection ID. If that one equals 1, do that. If not, equals that. It means that over here, we do need to pass that in. So let's go the connection ID, go inside network ID, grab the value, and grab the value. Okay, yep, so just like this, right now everything should still be working the same, except right now our code is much more higher quality. Right now things are much more nicely decoupled. Over here, the Go in-game client system, this one literally just handles what the name says. It just handles the going in-game, just handles that, adds that component, and then fires off an event, and does not care if anything is listening to that event. In this case, we do have the game client system. This one runs just on the clients, and this one is indeed listening to that event, and then decides to do something with it, which in this case assigns the local player type. So yep, this is great, things are now nicely decoupled, but over here we have an interesting question. So right now on the other side we are spawning this event, okay great, and then over here we are listening to it. But like with RPCs, should we also destroy this event entity, or should we keep it alive? Now when working with normal C# events, they can have multiple listeners, so if we were to follow that pattern, it would make sense to leave it alive over here. That way other classes could also listen to it if they wanted to do something. If the goal is to emulate C# events, and I think that approach makes sense, so let's do exactly that. Basically, let's make another system that is going to be responsible for destroying this event entity. Okay, so here let's go ahead and let's create a new entities system named the reset.events client system. And yep, over here, once again, this one is a client system, so let's begin by making sure that is correct. So run on the clients or the thin clients. And over here, importantly, since this one is basically meant to reset the dots events, for this we want to make sure this one runs at the end of the frame. So we essentially have the entire frame for multiple systems to read through these events. And the way we do that is quite simple. Just up here, we can add the attribute update in group, and we can use the group. Let's do type of the late simulation system group. Like it implies, this one runs at the end of the simulation. So pretty much the same thing as a normal late update. So we can update in this group and then use the other optional parameter, in this case the order last. Let's set order last equals true. So this system will run at the very end of this group, which is basically at the very end of the frame. Okay, so then on update, let's just cycle through that event. So do a for each, cycle through the ref.ro for the on connected event, call it on connected event, and then we're also going to need to destroy it. So let's also include entity. So you have this in system API.query. Let's query first of all for the ref.ro on connected event. So we have this, that's pretty much the only query, just with entity access like this. Okay, so now here let's just destroy the entity. So we can just create an entity command buffer. Let's construct a brand new one with allocated.temp. So we do that, then at the end we call playback, pass in state.entityManager, and over here the entity command buffer. Let's go inside that one and call destroy entity and destroy this entity. Okay, great, so this is it. Right now this should be working correctly. So basically we have the Go in-game client system. So this one runs, it's going to set the client as in-game, and it's going to fire off this event. So basically just creates an entity and attaches a component. Then we have the game client system. That one is decoupled from the other one. That one just listens to that event, and when that event is triggered, it assigns the local player type. And finally, at the end of the frame, we have the reset.events client system. This one runs at the end of the frame, cycles through all the events, and destroys them in order to make sure they have been consumed. So that's great, this looks correct. However, we actually have one potential sneaky issue here. We might or might not have an issue. It's actually semi-random. The potential issue has to do with the ordering of the systems and how that ordering is basically different on different PCs. So maybe on my PC this has an issue and on your PC it does not, or vice versa. Basically the issue is one of timing. If this system, the Go in-game client system, if the system that fires off the event, if this one happens to run after this system, after the system that listens to the event, if so, then basically that one is going to fire, then this one over here is going to destroy, and the game client system never knows the event actually happened. So in order for this to work correctly, we need the Go in-game client system, this one to run first, then this one to run second, and this one to run at the very end. Now this is actually a very annoying issue. I'm not entirely sure what is the best way to solve this sort of sorting issue. Usually you never want your code to be dependent on any specific ordering. Usually you want to avoid it as much as possible. Now there are multiple possible alternatives, but honestly I don't really love any of them. For example, one option would be creating a system group for the systems that fire events, and then another system group for systems that just listen to those events. Then we could easily order those perfectly. But sometimes you have some script that both listens to event and also invokes it, so that wouldn't really work. Another alternative would be to have the system that fires off the event be also the one that is responsible for destroying the old events. So over here, when this system runs, at the very beginning, before run any code that might invoke an event, we would basically run the cleanup code before it. That way the order wouldn't really matter. Technically, the listening, that one could happen one frame behind, but in most cases, chances are that's not really an issue. Being one frame behind on events probably doesn't really matter in most cases. However, what is an issue is once again you might have different systems all firing the same event. If that happens, then you can't really destroy the event before that, or rather you would have to choose one of those multiple systems that fire the same event type, one of those to be responsible for destroying that event. So again, I really don't know a very clear way to solve this problem. Now in this case, this game is actually pretty simple. So in this case over here, pretty much any approach will work just fine. But on a more complex game, I definitely would like to have a more scalable approach. I would possibly experiment with a bunch of those alternatives to see which one works best. I do think perhaps the best option of all would be the second one that I said, meaning the system that invokes the event would also be responsible for cleaning it up beforehand. In order to solve the other problem, we could really just make a rule to make it so that each event type can only be fired by one specific system. So if other systems want to fire off a similar event, they just have to be a different name. I think that would be the most scalable option, but also a little complex to write, and perhaps a bit confusing to understand, since the events might be behind by one frame. So like I said, over here on this super simple game, we can go with any approach, and let's really go with the approach that we already did. So let's go with the approach of resetting all the events at the end of the frame. In order for this one to work, we really just need to make sure to set up the ordering over here on this one. So on this one, we can just put this one, update after, and put the type of, and update after, in this case, the Go in-game client system. So yep, this way, this one is guaranteed to run after this one, which means this one fires, this one listens, and then this one cleans it up at the end. Again, I really don't like having code dependent on specific ordering, but this is a way to do it. This way it will always work. Okay, so yep, so we wrote all of this. Now we can finally test. So here we are, and yep, right away we can see it working. This one is assigned the cross, and this one is assigned the circle. So yep, everything still works exactly the same as previously, but now our code is much cleaner with some nice decoupling between the in-game state and initializing the player type. Alright, awesome. Now finally, when it comes to events, we can do one more thing. So right now, this over here we define as a dots event. It exists inside an entity. So that's really great for this particular use case, when we want to listen to those events within dots code. But in the next lecture, we are going to set up our UI, and that UI is going to be based on game objects. So to prepare for that, let's actually make our project able to also fire normal C# events. This is going to be quite easy, so let's do it. First, let's make a normal monoBehavior class. So create a new one, and let's call it dots events monoBehavior. So if this is it, this is going to be a normal monoBehavior. So let's make a game object to run it. So over here on the hierarchy, create a new empty game object with the exact same name and attach the script. Let's reset transform and let's open. And now on this one, for example, let's have some normal events. So we have public event, event handler. So the usual stuff on client connected event. So if you have this, and for example, let's also add the event arguments. So class on client connected event args, extend event args, and inside a public int for a connection ID. Then this event is going to be of this type like this. Okay, so yep, there's a standard normal C# event. And now the question is, how exactly do we invoke it? Well, it turns out we can actually interact with objects from dots code. So for example, over here on the reset dots event client system, this one is a nice system, but over here we can indeed call that function. We can indeed call managed objects. The one limitation is we cannot use burst. Over here, burst compile will not work, so let's remove this. If we interact with managed code, we cannot use burst, but we can still use it. So over here, when we consume that event, we can actually trigger that normal C# event. So over here, let's just expose a function for it. So a public void trigger on client connected event, and let's pass in the int for the connection ID, and then really just invoke it. So on client connect event, let's invoke with this new event args in the connected ID equals this connection ID. So we have this one, and now in order to be able to easily call this, let's implement the super useful singleton pattern. So static dots events monoBehavior, call it instance with a public get and a private set. We have this, and then let's make a private void awake, set the instance equals this. Okay, yep, great. So then over here on the dots reset events, on this one, let's go on the dots events monoBehavior, access the static instance, and call the trigger on client connect event, and pass in the onConnect event, go inside and grab the connection ID. Alright, so yep, just like this. We can test to verify this is working. So over here, just for testing, let's listen to this event. So let's listen to it and just do a debug.log on this one right here. Plus, let's also print out the e.connectionID. Okay, yep, so like this, let's test and see if this normal C# event is triggered, so normal C# code if it is running. So let's save it. Let's wait for it to compile and let's test. And yep, right away it does work. Look at that, we have the dots events monoBehavior. That one triggered that event and did correctly pass in the event data. And same thing on the other client. Yep, the event was triggered with the correct connection ID. So yep, awesome, everything is working. We've got dots events being handled in dots world, and then over here we are calling this normal function over here on this normal mode of behavior, and this one is invoking a normal C# event. So here we built a nice event system that supports both dots events and C# events. Like I said, these C# events will be very useful when handling our UI. We're going to do that in a little bit, but before that, let's just clean up our code, so get rid of that, and that. So there you go, everything is nice and cleaned up, so everything does work. And now let's put these C# events to use with our UI, so let's start building that in the next lecture. Alright, quick intermission here. How are you getting along with the course? Are you finding it difficult or easy? Did you watch the Netcode for GameObjects course before this one? Did you watch my Dots course or my Netcode for Entities video beforehand? If so, are you finding this one easy to understand if you followed all of that? I hope so. I'm hoping that this course can also help you understand dots more easily if you followed the other ones previously. If you already made basically this exact same game using Netcode for GameObjects, hopefully now it's becoming quite a bit more easy to understand how dots work by remaking the exact same game but using a different tech stack. Personally, I really enjoyed building both these courses. It has been an interesting challenge to figure out how to make the exact same game with two completely different technologies. So yep, I hope you're learning a lot. I hope you're taking the time to do all the quizzes and frequently asked questions. And of course, if you get stuck on anything, remember how you can download the project files and compare directly with your own. Or if you need some deeper explanation on something, if so, then feel free to post in the comments and I'll do my best to help. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a player UI to show the current player, and in doing so, we're also going to set up our canvas. Okay, so we can now currently place some objects. One side plays crosses, the other side plays circles, so that works. But right now, the only way of knowing which one we are playing, the only way of knowing that is by reading the console, so let's make a nice UI to display that. And as usual, when it comes to UI, usually you want to do it with game objects. Technically, you can make the UI all dots based, but it really just becomes needlessly confusing. So let's use a normal game objects for the UI. Let's begin by over here outside the subscene, let's make a new UI, make a new canvas. And over here on this canvas, let's put the simple setup that I normally use. So over here on the canvas scaler, let's scale with the screen size, reference resolution of 1920 by 1080, and let's match fully with the height. So yep, this is the setup that I like to use. Let's place an image to see what happens. So inside the canvas, a new UI image. So yep, there's that image. Basically, with this setup, it means that as we change resolution, so if I change over here from 16 by 9 to let's say 5 by 4, as I change that, this element over here did not scale at all. The anchors on the corners, those will move, but the objects will not scale. Basically, they only scale if the vertical resolution, if that one changes. If that one changes, then it does scale up or down in order to keep the exact same relative size. But if the horizontal side, if that one changes, we go to that, nope, that one does not scale. Now, personally, I really like this setup because it means that I can position everything I want with a small aspect ratio, like for example 5 by 4. So I can position everything correctly relative to all the anchors and all the corners over here in 5 by 4. And if everything is playable in this resolution, I know for a fact that it's playable in literally any resolution. So yep, that's why I like the setup, so let's use this. So yep, our canvas is set up, nice. Now inside the canvas, let's create a new empty game object for the player UI. And over here on scene view, let's see the whole thing. Okay, first let's stretch it out. So over here, let's hold down Alt. So over here, let's hold down Alt. So over here, let's hold down Alt. And let's click over here to stretch the whole thing. So 0 on everything. Okay, great. Now inside, let's make a background. So a new UI image, name it the background. For this, let's put it in just black. Let's anchor it to the top right. Let's hold down Shift to also set the pivot. Then let's put it on a Y of 0. And let's put it some kind of scale. So let's say width 550, then 130, something like that. Now inside, let's make an image of a cross. So inside on the UI, over here, actually, instead of using an image, that one takes a sprite. And since over here on this game, we just have materials, because that, instead of using an image, let's use a raw image. This one takes in a material. So let's use that one. And for the name, let's name it the cross raw image. And over here, we can assign the cross material like that. And if there it is, there's our object. Then let's anchor it to the top. Let's put it on position on the Y of -55 like that. Then an X of -50 and width and height of 80 on each. Okay, great. Let's duplicate this to make the circle raw image. Let's assign the circle material and put it on +50 like that. Okay, great. We have our two symbols. Now let's also just move the camera a little bit. So on the main camera, let's put the orthographic size on 6, make it a little bit more zoomed out, and lift it up a bit. So on the one, let's put it on 0.8. Okay, great. Let's also just scale the background. So let's open up the subscene, go inside of it, select the background, and let's just move it just to occupy the whole thing. Okay, great. Now let's write U underneath each of our symbols, and we're going to enable the one that represents the local player. So inside our canvas, let's create a new UI, a text mesh pro. And if this window comes up, let's import the text mesh pro essentials. Okay, we have these. Let's name this one the cross U text mesh. For the text, let's say U, put the width and height both on 0, put it in bold, font size of 20. Let's put it down center, vertical center, disable wrapping. Yep, just like that. Let's anchor it to the top, and let's put it on -50 in order to be right up there. So let's put it right under symbol. Okay, great. Then same thing for the other one. So duplicate it, and this one is going to be the circle U text mesh. So we have this one on x of +50. Okay, that's great. So final thing we need is just an arrow image to show which one is the current playable player type. So on the PlayerUI, let's create UI. In this case, let's make an image. Let's do that because that one is set up as sprite. So for the cross arrow image, and over here on the project files, on the textures, yep, we have the arrow. This one is marked as a sprite, so yep, that one does work. Let's anchor it up top, and then let's move it in order to put it all the way in there. So this one is the cross one, so let's put it over there. Put it on a size of 80 by 80, just make it a little bit smaller. Okay, put it there, then another one on the other side. Let's rotate it on the Z by 180 degrees. And yep, just like that, and name this one, this is the circle arrow image. All right, yep, just like that. So here we have our nice setup. We have all these elements that we can now control through code. So let's make a script for that. So inside our scripts folder, let's create a new one. This one is going to be a normal mono behavior called just the PlayerUI. Let's select our object, let's attach it and open. Okay, so yep, again, this one is just a simple mono behavior. So let's drag our references as usual, like a normal mono behavior. So serialized field, private. Let's put a game object for the cross arrow game object. This is the one that defines which one is currently playing, so the cross and the circle. Then let's also have the U, so the cross U game object and the circle U game object. So yep, these are all our elements. Again, just a normal C# mono behavior. Then over here, let's just drag those references. So let's go for the cross U text mesh. That is that one. For the circle U text mesh, which is actually named circle. So let's rename this circle. Okay, great. Then for the cross arrow, like that, and the circle arrow like that. Okay, so now let's just hide them all by default. So on awake, cross arrow game object, set active into false, and do the same thing for all of these. So the circle arrow, the cross U, and the circle U like this. Okay, great. So yep, our UI is all set up. We've got the background, we've got all the elements, and they're all referenced through code. If we hit on play, if there it is, they all start off as disabled, they all start off as hidden, exactly as intended. All right, awesome. So here we set up our UI, so everything is ready for applying some logic. So let's build that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to handle the logic to start our game. After starting the game, we're then going to update the player UI to show the local player type. Okay, so in the last lecture, we already built our UI. We have all the references to all the elements. Specifically, we have the U indicators. By default, they start off as hidden, and then when we have two clients connected and we assign the local player type, when we do that, then we want to show the U that represents the local player type. Now, once again, if we were writing normal object-oriented programming, here's where I would make a start function, then that one I would hook onto any C# events for any data that I need to update this. That's what I would normally do, but again, dots is different. Although thankfully, we already made our nice dots event system, so we're going to be able to use this for the U text, even though we're actually going to need a different method for the next lecture for handling the arrow game objects. But before that, let's handle the U text. This one's going to be relatively straightforward. We are assigning that one over here on the game client system. So this one listens to the dots on connect event and assigns this one. So the simplest way to update our player UI would be over here we have the dots event on client connected. So we can listen to this one and then update the U depending on the local player type. That would work, but we're also going to need to apply some extra logic when we have the start game when two clients have connected. So let's actually handle that logic and then hook onto that event. Like I said, the game starts when two players are connected. So over here on the GameServerSystem, over here we can easily check for the number of connected clients. So let's go over here on our onUpdate. And here let's check for the connect clients, which is quite simple. We really just need to do a query for the network stream in-game. So let's create an entity query for the network stream in-game entity query. So let's construct a brand new one. So state entity manager, let's create a new entity query. Over here for the components, type of network stream in-game. Okay, yep, so we have this entity query, and inside that one we can calculate the entity count, so we can check if the entity count, if that one equals 2. If so, then yep, the game is ready to start, so let's start our game. By the way, previously we were doing this. We were constantly on update, constantly checking if the player type is none, and if so, then assign to cross in order to start. Now that we have this proper logic, now we can do that over there. So let's put that one in there. Let's just put essentially this one inside this up here. So we grab the game server data, then we check if we have 2 entities, and if so, then let's assign that one. Okay, so that's great. This is the player start. Now, once again, always remember what code is running on the server versus the clients. Our goal right now is to update the player UI, and the UI obviously only exists on the client. Whereas right now, the game server, this one is running on the server only. So if we want the clients to be notified when the game starts, if so, then we need to make a client RPC. So here, let's define that. So in our RPCs, create a mono behavior for the game started RPC. And this one is going to be a struct and implement IRPC command like that. And we don't even need any extra data, so just like this. And now we can go here on our server system. And on this one, let's just fire off that RPC. So we can just go state entity manager, and let's create an entity with type of, with the game started RPC, and also a type of the send RPC command request. All right, yep, just like this. And again, since this one is going to be fired from the server, because that, we don't even need to define any data over here on the send RPC. We don't need to define a target because we do want this one to go from the server to every connected client. Okay, yep, so this should be working. Let's do a debug.log, just print out start game, and this should be working. So let's do a quick test and look at the logs, and technically it did work. So over here, start game, that one is working as 2 clients are connected, so that's great. But of course, this is an issue. Like this, it is sending the RPC constantly all the time on every update. Obviously, we just want to start the game once, so let's add some simple logic to keep track of that. Let's go here on the game server data, and let's basically define a very simple state machine. So let's make a public enum, call it state, and for our possible states can be waiting for players, or we can be game started. So yep, like this, and then a public state for our state. And by default, yep, it will be waiting for players, actually like this. So then over here on this one, we've got the game server data, and we check if this one, let's read the state. If the state is waiting for players, if so, then yep, let's do that logic. And then when we start game server data, let's write to it, write the state, and in this case, put it as game started. This way, if 2 players connect, the game should start just once. So yep, let's test. And yep, right away it works. So both clients connected and we start the game just once. Okay, great. So now we can listen to this RPC. So let's go on our game client system. So on this one over here, let's handle that. So up here we are handling the onConnected event. And then down here, we're handling the game started RPC. So let's do a for each on that one. For each, we're going to have a ref.ro game start RPC, game started RPC. Then we're also going to have an entity. So we have both of these in system API. Let's do a query ref.ro game started RPC. So we query for this one with entity access so we can consume the RPC. Okay, so here let's make an entity command buffer so we can queue up the destruction of our RPC. So allocator.temp. So we do that one. Then at the very end of the update over here, let's call playback with state.entity manager. Okay. And over here, let's destroy this entity for our RPC entity. Okay, so far so good. So all that's left is over here invoking some kind of game start event. So for that, since we want to fire off a C# event, let's go over here on the .events mono behavior. Let's make another one, public event handler on game started, and let's expose a function. So public void trigger on game started. So like this, and we really just invoke the normal event. So this event args.empty. So yep, we have this one, and then over here, when we have that, let's go in the mono behavior, the instance, trigger that one like that. Okay, great. So we can finally now go into our player UI, and over here on the player UI, let's do a private void start. Let's listen to that event. So mono behavior, the instance on game started. Let's listen to this one on the events mono behavior. So we have this, and if it's now here that we can easily update our UI. And for this, also a little bit tricky, just because the local player type that is on client data component, meaning it's not normal C# data. So we're going to need to access that. We're going to need to access over here the game client data. And normal .code, we can easily just access the system API get singleton, but we can't use the system API outside of a system, so we can't use it over here on the player UI. So we need to do it manually. The first thing is we actually need to go through the world. And usually in working with dots, usually use world.default game object injection world. This one that you usually use. However, over here, let's do a debug.log to see what this one says. So let's log it, save all our files, and let's see. And you have a look at that. So over here on this one, on the host, this one, the default world, that one is the server world. But down here on the client, this one, the default is the client world. So yep, this is the issue. The data that we want to grab, that one exists on the client world. So if up here on the host, if we use the default game object injection world, if so, then we are going to be using the wrong world. So over here, instead of using this one, instead of that, we want to make sure we always grab the client world, whether we are on the client or the host. And thankfully, that's actually quite easy to get. In the beginning, when we made our bootstrapper, we extend this class, the client server bootstrap. And inside this one, yep, here we actually have a static property for the client world. And yep, this way we always make sure we always grab the client world. So if we have that one, then inside the client world, just the usual stuff. Let's grab the entity manager for this one. So entity manager on that one. Then from the entity manager, we can create an entity query. Query, let's look for, in this case, we want the game client data. So let's look for that one. So entity query for game client data entity query. Let's grab that one. Then inside that one, we can call the get singleton function. Get singleton of type game client data like that and store it over here. So game client data, game client data. All right, yep. So we go through the correct world, grab the entity manager, create the entity query, then execute it, grab the singleton, and here we have our data. So yep, now it's pretty simple. Now we just check, go inside that one, get the local player type, and if that one matches player.cross, if so, then let's enable the cross U. So cross U, set it into true, and if not, then let's do the circle U, set into true. So yep, just like this, let's save and let's test. And if right away we do see everything is working, so up here on the host, this one was assigned the cross, and over there on the UI, yep, we can see the cross, so it got the GameStartRpc and updated it. Same thing down here on the client, we can see this one is playing the circles, and the game started, the RPC was received, so everything works perfectly. Over here, take an action, yep, everything works fine. Alright, awesome. So yep, here we handle the U sign, so we handle being able to show on the UI what is the local player type. Now the next goal is to handle the arrows that show which one is the current playable player type. And for synchronizing that, for that we're going to need to learn about ghost fields, so let's learn about those in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about ghost fields. This is how we can synchronize constant custom data. Okay, so here we have our UI, and the UText, that one already works. So as soon as we connect, it checks, okay, this one is a local one, so it enables that one. This one is a circle, so yep, we can do and we can verify, yep, the whole thing works. Now, next thing we want to implement is to showcase the current playable player type. And for this one, we just have these arrows in the UI. So we just need to know which one is the current playable player type, so either cross or circles, and enable this arrow and disable this arrow. So now for this one, like I said, in normal object-oriented programming, in there I would just make a normal event and fire it whenever we modified that one. So here on the GameServerSystem, when we are taking an action and we modify it, so it's over here that I would basically invoke a C# event. Now here, when working in dots, we can't use normal events, we can't use objects, but we can use an RPC. So over here, technically, we could fire an RPC and then listen to that RPC and update the UI. We could do that pretty much like we did with the GameStart logic. That would work, but for learning purposes, let's go ahead with a different method. So over here on our UI script, instead of updating it based on an event, so updating only when that value changes, instead of that, let's just update it constantly. Now, technically, that's going to be less performant since we're going to be wasting a tiny bit of CPU by updating all the time, even when things are not changing. So technically, it's a little bit wasteful, but at the same time, this code is going to be so fast and so tiny that it doesn't really matter. And importantly, I really just want to show you multiple ways of solving the same problem. So yep, let's do something that basically polls for updates. So first, let's make our function. So let's call it update current playable arrow. And we're going to call this one on the update. So let's go up here, make a private void update, just standard, call this function like that. Okay, so now over here on this function, the data that we want to grab is over here on the game server data component. It is this one, the current playable player type. So we want to grab this one, and this data exists on the server. However, also importantly, the UI exists on each client. It does not exist on the server. So this is a little bit of a tricky thing. We want to get the server data, but we want to grab it on the client and not the server. Always keep in mind how we have multiple worlds, especially if we have a host. We've got a client world and a server world. And over here in this game, we are assigning this data only on the server, but the client still has this component, it just isn't assigned to anything. That's actually going to be the exact problem that we're going to see in a little bit. But for now, just keep in mind that we are running the UI runs on the client, but we want to grab this game server data component. So over here on our UI function, Previously, when we grabbed the entity manager, we did this. We went through the client server bootstrap and grabbed the client world. And over here, again, even though we are trying to get the server data, we want to do the same thing. We want to grab the client world because again, this UI, this one is going to run on all the clients, not just the host. And normal clients, they don't have a server world, they just have a client world. So we want to make sure we go through this one and then do a query. So let's actually copy exactly all of this, except instead of being the game client data, we want to grab the game server data. So let's grab this one of this type, modify the query, and this one is the game server data, and it's also the server data entity query. Okay, yep, so just like this, so we have that one. And now let's just do a log on that, just to see what that one contains. So game server data, go inside, let's log the current playable player type. And essentially what we want to do is just enable or disable the arrow game objects. So over here, we can just do an if, go in the game server data, let's grab the current playable player type. And if that one matches the cross, if so, then let's display the cross arrow. So the cross arrow game object set active into true and set the circle arrow game object into false. If not, then let's invert those. So for this one up here, become false and this one become true. Okay, so yep, just like this. Like I said, it's actually going to have an issue, but let's save it and let's see what this log says. And yep, right away, and look at that, it is not correct. It is saying that the circle is the one meant to be playing, when in reality it's the cross. And actually, if we look on the console, it is actually not saying that it's a circle, instead it is saying none. And if we take some turns, yep, that one never updates, it just stays stuck, always stays stuck on none. And the reason why it's saying none is because this field over here, this one that is on the server data, that one is only being set on the server and never on the client. So this is the issue that we have to solve. We do want to get the data on the server, but we want it to be synchronized across the clients. We need the clients to be able to know when this field changes on the server. And for this is where we have ghost fields. Now, previously we already learned about ghosts. These are the objects that are automatically spawned and synchronized across the network. So when a ghost is spawned on the server, it automatically gets synchronized to all the clients. And in doing so, the ghost also automatically synchronizes the local transform data. So as the object moves and scales, it gets synchronized accordingly. However, what about other custom data that we want to synchronize? Like for example, the current playable player type. For that one, that's where ghost fields come in. We need to mark a field as a ghost field, and in doing so, that field will automatically be synchronized across the network just like the transform data. And the way we make a ghost field is super simple. Literally is just use the attribute ghost field, exists inside unity.netcode, just like this. And yep, that is pretty much all we need to do. Like this field will now be treated as a ghost, except it actually still needs one more thing, so let's save this. In order for this one to be synchronized as a ghost, if so, then the object where this component is attached to, that one also needs to be marked as a ghost. So over here in our game, on our subscene, we've got the game server data. And like I said, for that one to be synchronized, let's go ahead and add the ghost authoring component, which in turn means this one also has to become a prefab. So let's go up here, mark this as a prefab. And if that's it, now this should be working. Then over here on the UI code, we are already doing everything correct. So we're grabbing the game server data, the one that exists on the client world. And again, because we marked that as a ghost field, because the data inside of it won't be synchronized. So this field right now should not be saying none, it should be correct. So yep, let's test. Okay, so here we are, and right away we can see it is actually working. We can see the arrows on the correct side, and over here on the logs, we can see the cross instead of none. And now if we take an action, yep, there you go, that one updates in there, and also updates over here on this client. All right, awesome. By the way, here it actually spawned an error. Over here we are seeing an invalid operation. The get singleton requires one instance, but exists 0. This has to do with how the subscene actually takes a while to load, basically doesn't load absolutely instantly. So over here on this code, for the on-game start, this one is only going to trigger when the subscene is loaded, so this one is always going to work. But this one down here, this one is running just on the update. And like I said, the subscene might take a few frames to be initialized. So down here, this get singleton might not work. So we just need to add a simple check just to keep the code safe. So over here, let's go into query, check first, has a singleton of type game server data. And if not, if it does not have the singleton, then let's just return, let us not do that. If it does, then let's do this. So yep, now we can also get rid of this testing and everything should be working. And also same thing over here on the GameServerSystem. Since we made the game server data a ghost, because that it will only be spawned when the connection is marked as in-game. So once again, when this one runs the on update, this might not yet exist. So in this case, we can add it up here. So state require for update of the game server data like that. Okay, so yep, like this, if we test. And if there it is, no errors, everything is fine. And we can see the errors being synchronized. So right now it's the crosses. Over here, take an action. Yep, there you go. It swaps to that one, and this one sees the change, and so does this one. So yep, here we have some nice custom data, all of it being constantly synchronized. When the server changes, the client gets notified of those changes automatically. So on each client, we know both which player we are and what is the current turn. Okay, great! By the way, since we're talking about ghosts and how they are actually relatively similar to RPCs, meaning they both allow you to synchronize some data, here's one example where that difference is quite impactful, which is in the concept of late joining clients, meaning clients that join after something has already happened. If you use an RPC, for example, if you use it to open some kind of chest, so the chest starts off as closed, then the server sends this RPC onto the clients and the clients open up the chest. If you do that, then any clients that join late, they will have the chest remain closed because RPCs do not get automatically resent to late joining clients. If the client is connected when the RPC is sent, they receive the RPC. If they are not connected at the time, they will not receive the RPC even if they connect afterwards. Whereas if we are working with ghost fields, if we mark a field as being a ghost field, and again, we do the same thing, so we use that synchronize the chest from being closed into being opened. If we do that and then a client joins later, when the client joins later, that one receives the latest snapshot that includes the chest state as it is currently. Meaning that even if a client joins late, they will still receive the state that says the chest has been opened. So yep, even though both RPCs and ghosts are both different ways of synchronizing data, do keep in mind how they work differently. RPCs are basically one-off messages, whereas ghosts, those are basically constant data constantly being synchronized. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to define a player type array to store the current state of our board. Okay, so our game is working nicely, we can place objects and we can take turns, so that's great. Except we actually have an issue. If we take a turn and then we try taking a turn on the exact same grid position, if so, then yep, that does work. So I can place multiple symbols on the same type, on the same place, and it does work. The game does not stop that. Obviously that's an issue, we should not allow this. We should not be able to take a turn on a position that is already occupied, so let's solve this. And for this, it's actually pretty simple. We basically just need to keep track of the board state, so keep track of what symbols are in what grid position and make sure we don't allow multiple symbols on the same grid position. Now to store the board state, let's use an array, but arrays are actually quite tricky in dots. For example, normal C# arrays. Over here, if I do player type array, this is not valid. We cannot do this in dots. These arrays, these are object types, so we can't use this in dots components. Now, usually in dots, if you want a collection of elements, if so, then usually what you want to use is a dynamic buffer. We could basically define a component for our grid data and then make a dynamic buffer of that type. Then we could add multiple elements of that type. So that works, that's one way to store multiple elements inside a component. But another alternative that would be actually better in this case is how technically we can actually have arrays inside of our components, except not really, or rather there's one tricky sneaky issue. So it's possible, but also not possible. Let's see how. First of all, over here on the game server data, if we try to add a native array, which again, native arrays are value types, so technically they can be used in components. So if we do native array of type player type, and native array exists inside unity.collections. If we do this for the player type array, okay, yep, just like this, if we save, and here in the editor, nope, we have an error right away. It is telling us that the game server data, that one contains a potentially nested pointer field. So this does not work. We cannot have arrays or lists inside dots component. Except that's not really right. We can actually do that. The one limitation is how we cannot do that within the baking system. So here for this component, we are adding it during bake time. And at bake time, we cannot have arrays or lists inside a component. But if we create this array at runtime, if so, then we can indeed have it inside a component. So let's do exactly that. First, over here, let's make two components. One that is going to be added through the baking system, and one that we're going to add at runtime. So over here, let's make a separate one, a struct, call it game server data arrays. And this one is also an iComponent data. And now on this one, we are indeed going to have this field. Yep, just like this, exactly the same, except this one does not go through the baking system. If we save our code right now and compile, yep, there it is, we have no errors, so no issues. Now over here on the GameServerSystem, on this one, let's go down to here where we are starting our game. And over here, let's initialize and create that array and that component. As to where we add it to, we can actually add it to the exact same entity that contains the game server data component. So let's do a system API, get the singleton entity of the game server data. So you grab this one, that's the entity for the game server data entity. And then we can go state entity manager and we can add a component on the same entity. So the game server data entity. And let's do a new, in this case, the game server data arrays like this. And just here, it's actually add component data, not add component. Okay, yep, so just like this. And over here, we've got the player type array. So we just need to construct and initialize this one. So to build it, let's do a new native array. And first, we are going to need the size of our array. So the size, our grid is fixed. We've got a 3x3 grid. So let's actually go up here and define a simple constant. So let's make a private const int for the grid with height, and it's 3. That's the size of our grid. So over here for the size is going to be the grid with height times that one. And then finally, let's use allocator. In this case, we want this one to persist, so let's use persistent. Okay, yep, like this. And since over here we made a persistent allocation, because that we should really clean it up. So let's go down here. Let's make a public void on destroy, receive a ref system state for the state. And over here, let's go on the system API, get the singleton that contains the game server data arrays. So this is going to be the game server data arrays. We have this one. Then inside that one, let's read the player type array and dispose of it. And sometimes this can cause issues if the entity gets destroyed before the system. So before that, let's just do if go inside has the singleton, game server data arrays. If it does have the singleton, let's destroy it. If not, then it's already been destroyed. And the whole thing can also use burst compile, just make it a little bit faster. Okay, great. So here's our cleanup. And up here we are initializing our array. So again, here we are adding a component. Inside that component, we are adding a native array. And like this, if we save and compile, yep, there it is, no errors. And if we hit on play, yep, also no errors, and the game is working perfectly fine. So yep, this is one of the interesting quirks of Dot. You cannot have arrays or lists inside components through the baking system, but you can if you build them at runtime. Okay, so here we have our array. We just created it, so by default, all of the grid positions, those are all going to be set to none, exactly what we want. This is a 3x3 grid. And now down here, when we place an object, so first we check if it's this player's turn, and then it's over here that we want to check if the position is clear. So check if grid position is occupied. And over here, we've got the X and Y of where we clicked on. So we really just want to check that one, check if that position in the array is empty or not. And of course, here we have another question. When it comes to defining a grid that has both width and height, usually I would make a 2D multidimensional array. But in Dots, those are a little bit tricky, so that's why over here I define it as just a normal flat array. This isn't an issue, it really just means we need to do one special thing. We basically just need some math to convert from a grid position onto a flat array index. So let's go down here and make a nice helper function to do exactly that. So private, we're going to return an int, call it get flat index from grid position. Take an int x and int y. And here just some super basic math to convert it. So we're going to return, and basically for the grid, we have a 3x3 grid. And in terms of indexes, then this one is going to be on index 0, index 1, index 2, 3, 4, 5, 6, 7, 8. So essentially the index is going to be the y position, so the height. That one multiplied by 3, so the grid width and height, plus whatever value we have on the x. So down here on position 0, 0, that is going to be 3 multiplied by 0 equals 0, plus 0 on the x, so the whole thing is 0. And for example, this one over here, this one has a y of 1, so we do 1 times 3, that brings us index 3, and then we add the x, which in this case is an x of 1, 3 plus 1 equals 4. And if we check the index, okay, this is 0, 1, 2, 3, and yep, this one is indeed 4. So yep, just some basic math, just y multiplied by the grid width and height, plus the x. So yep, nice helper function, and now up here we can check that. We can first grab the game server data array, so system API. We're going to need to modify it, so let's get the singleton RW of the game server data arrays. Yep, let's grab this one, so ref RW, game server data arrays, like this. Okay, we have this one, and we check, go inside this one, read the value for the player type array, then get the flat index from the grid position, and the grid position is the one clicked on, value x, clicked on, value y. So we get that index, and we check that one, and we check if this one is not none, meaning position is already occupied. And if it is occupied, then we don't want to take an action, so we want to skip, so let's do a continue. And if it isn't, if we do get down here, then the position is not yet occupied, so let's basically modify it. So let's grab that same one, except over here, value RW, and we're going to set it to this current player, which is on the clicked on grid position, read the value for the player type. So yep, just like this, really simple. Just go inside the array, check if it's empty. If it is not empty, skip it. If it is empty, assign it. So yep, let's go ahead, save and test. Okay, so here we are, try to play crosses. Okay, now down here, try to play circles on the same position. And nope, it does not work. It is capturing the clicks, but nope, that position is occupied. We cannot put it there. So let's put it over there, and then over here, try to put cross on the same position. Nope, does not work, needs to go in there. So yep, we can no longer take positions on the exact same place, so now our game rules are much more correct. All right, awesome. Hello and welcome, I'm your code monkey. In this lecture, we're going to create a function to test if we have a winner. This is pretty simple. We basically just need to check if we have 3 matching symbols in a row. Okay, so our game is looking nice. We can take turns and we can place objects on both positions. That's great. But if we make 3 in a row, nope, nothing happens. The game really just continues as normal. So the one thing missing right now is checking if we have a winner. Let's make the function to test for that. And as always, the game is server authoritative, so let's run it on the server. Over here on our GameServerSystem, let's go down into the bottom and make a nice function. So private void test winner. Okay, now here for the win logic. For this game, it's actually pretty simple. We really just need to check if we have 3 of the same type in a row. So for example, we just go through the bottom row, check if position 0, 0, 1, 0, and 2, 0 if all of those match. If so, then we have a win. Meaning that over here, we really just need to grab over here the player type array. We just need that one. And for grabbing that array, down here on this function, we have basically 2 options. One option is over here, obviously we could do system API, get the singleton and so on, so that works. Or we can pass it in as a parameter, either way works. Since we're going to call the testWinner function from up here from our update, and over here we already have the GameServerArrays, because that let's really just pass it in. So GameServerArrays like that. And then over here, let's just check those bottom 3 positions. So go inside the GameServerArrays, the player type array, and check position, get the flat index, position 0, 0, like this. So if we're going to check this one, let's make a simple helper function just to help us test if we have a winner line. So here, private bool, test winner line. This one takes in a player type for the A player type, then player type for the B player type, and finally another player type for the C player type. So these are the 3 symbols. And over here, let's just check if they match. So here we return and we basically just check. And first of all, let's check that it's not empty. Obviously, we don't want to have a winner line if all 3 positions are none. So first check if the A player type, if this one does not equal none, okay, so this one has something on it. And then check if the A player type matches the B player type, and check that the B player type does match the C player type. So yep, if so, A matches B and B matches C, so all of them match, so that is correct. And then down here, let's just call that function. So if test our winner line like this, and for our parameters, let's grab them just like that. So we got position 0, 0, then 1, 0, and 2, 0. So let's check, first of all, just for the bottom row, like this. So we do this, and up here, do a log, just say winner. And let's also reset the current playable player type so we can't play anymore. And for that, once again, let's receive it over here as a parameter. So ref_rw of the game server data. Let's pass that in. And then when we have a winner, go inside of it and write the value for the current playable player type, set it into none so nobody can play anymore. Okay, that should do it. So let's just call this function from up here. So the player takes an action. All right, makes sense. It spawns the player prefab. Okay, so then over here, let's test the winner. Pass in the game server data arrays, and then pass in the game server data. Okay, yep, just like this. Let's test, let's see. Okay, so here we are. Let's make a winner on the bottom. So let's place 3 crosses. So that one, and now as I click this one, yep, there you go. Yep, we have a winner. And right now the current playable player, that one was set to none. So now if I try taking an action, nope, doesn't work. So yep, we have our nice win state. All right, awesome. Now let's make a visual to show that we have a winner. So over here on the project files, I include a nice line green. So let's use this. For the visual, it's going to look very much the same as one of these lines. So let's duplicate one of these, name it the line winner. Just swap out the line green material. Something like this. Let's also make it a bit thicker. So here 1 on the Y. Yep, like that. Now for this one, we want to synchronize the spawning. So let's make it a ghost. And in order to make a ghost, this one needs to be a prefab. And let's remove it from the scene. Okay, great. Then in order to spawn it dynamically, let's add a reference over here on the entities references. So up here, make another one for the line winner prefab game object. Another one for the line winner prefab entity. Another one just like this. Okay, great. Let's save. Here in the editor, let's assign our line winner prefab. So now over here on our test winner function, over here, let's spawn the winning line. In order to spawn it, we need 2 things. We need an entity command buffer, and we need the entities references. So let's receive it over here, entity command buffer like that, and entities references like that. Then go on the entity command buffer. Let's instantiate, go on the entities references, grab the inline winner. So this returns an entity for the inline winner entity. Okay, we have this one. Now to position it correctly, let's calculate the world position for this one. So a float 3 for the world position. Basically going to get the world position. This one takes an X and a Y. So let's use the middle position of our 3 positions. So 1, 0 like this. And in order to make sure that it shows up in front, let's set the Z equals 1F. Again, even though this game is 2D, we are working with 3D objects. So to make it on top, really just move it closer to the camera. Okay, so like this, and then on the entity command buffer, let's set a component on this entity, so the align winner entity, and do a local transform from position and pass in this world position. All right, yep, just like this, this should be spawning the visual. Let's just go up here and pass in those. So the entity command buffer and also the entity's references. Actually, the position over here is on -1F, not 1F. Okay, yep, so let's save and let's test. Okay, so here we are. Let's make a win on the bottom. So place that one, and as I placed the last one, yep, there you go. We have a nice visual, so it shows we have a nice win. All right, awesome. So yep, the code is working. Now all we need to do is really just apply the exact same code to every single possible win combination. So 3 horizontals, 3 verticals, and 2 diagonals. And over here, we could really just copy paste this code a ton of times. Since this game has a fixed grid size, that wouldn't necessarily be too bad, but still it would be pretty long. And like I said in this course, I'm trying to teach you how to write good, clean code. So let's do it in a slightly more complex, but much more proper, much more dynamic way. First, let's define a type to define what is the concept of a line. So let's go up here, let's make it a struct, call it a line. And inside, for what data defines a line, we really just have 3 grid positions. And for the grid position, usually so far we've been using a separate X and Y. And that works, that's one way to do it. But over here, in order to store it on just one field, for that over here, we can just use, for example, an int2. This one is a struct, which, yep, takes in an X and Y, so exactly what we want. So let's call it the grid position 0. Then we've got the 1 and the 2, so we've got our 3 grid positions. And then for the visual line, we are going to need to be able to rotate it, and we need to know, is this line representing a line that is diagonal or not? So if so, let's also define an orientation. We can define it up here, just a simple enum orientation. And our possible orientations are, we have horizontal, then we have vertical, and then we have 2 diagonals, because one is plus 45 degrees and the other one is minus 45. So diagonal A and diagonal B. Okay, yep, we have those, and then up here just a public orientation field for the orientation. Okay, great, just like this. And all we need to do is really just build a list of lines. We do that to define all the lines, and on the test winner function, we can just cycle through all of those. So for building that list, let's go over here when we start our game. Over here, let's initialize our data. We can define a native array of type line for the line array, and do a brand new native array. For the size, like I said, we have 3 horizontal, 3 vertical, and 2 diagonal. So we're going to have 8 possible lines. And let's use allocated.persistent. So we do this, and then we are going to store this line inside this component. So we're going to put that one in there. Let's just modify this one. So up here, same thing, a public, a native array of type line, which the line actually exists on the GameServerSystem. So we have the line there for the line array. And here it's telling us we have an error with inconsistent accessibility. That is because over here we define the line as public, yep. But over here, Unity, the default template, that one omits the access modifier. And if you omit, then it becomes private. So let's make sure to make this system public. And yep, now here this error is going to go away. Great. Now over here, we initialize it, and let's just create our line array. Although actually just one thing, since we are initializing as persistent, let's also make sure to clear it. So down here, when we have the destroy, yep, we dispose the player type array and also the line array. Okay, great. So now we can finally add all of our lines. So let's add, for example, start with the horizontal lines. So let's set it on index 0 equals a new line. Let's build a brand new one. So for grid position 0, this one is going to be on 0, 0. Then we have grid position 1 and 2. So 1 is going to be on 1, 0 and 2, 0. So this is the bottom horizontal line. And for the orientation, this is a horizontal line. Okay, yep, this is our line. So let's make our 3 horizontal lines. So index 1, index 2. So that is going to be 1 on the Y and then 2 on the Y. Okay, these are all the horizontal ones. Now let's make the vertical lines. So for these are going to go vertically. So it's going to have 0, 1, and 2 on the Y. And then on the X, 0, 0, 0. Let's start with that one. Put it on index 3. And this one is our vertical line. Okay, that's 1. Let's make our 3. So 1, 2, 3. So index 3, 4, and 5. So we've got these. Then on the 1 on the X and 2 on the X. Okay. We have our vertical ones, and then finally for the diagonal line. And on this one, let's put it on index 6. And for diagonal, let's go on going left to right, down, up. So 0, 0, 2, 1, 1 to 2, 2. Yep, this is going to be diagonal A. And then another one on index 7. This one is going to start above and go down. So that's 0, 2, goes down into 1, 1, and down into 2, 0. And this one is the diagonal B. Right, yep, so we have created our line array, assigned all the possible lines, all the possible win conditions, and stored it over here on the game server data arrays. Great. Now with all this data, let's just go down into the test winner function. And yep, over here, instead of testing each line, let's just cycle through that one. So let's do a for each line, cycle through the game server data arrays, cycle through the line array, go like this, do a bunch of stuff. Here we check on this player type array, and let's grab the line, let's grab the grid position 0.x, and then grid position 0.y, and we're going to check our 3 grid positions. So 0, 1, and 2, 0, 1, and 2. Yep, we have those. Then for spawning it, let's spawn it on the center one like that. So the one on grid position 1. Okay, great. And finally, for the visual, we also need to apply the rotation in order to make it work on the verticals and the diagonals. So for that, let's define the Euler angles for it. So a float Euler Z. Let's do a switch on the line.orientation. And okay, in case we have a horizontal line, if so, then the Euler Z becomes 0. It's already correct by default, okay? Then we have vertical, diagonals, and so on. So we've got the vertical, the diagonal A, and diagonal B. Okay, we have those, and for the vertical, rotating it really just by 90 degrees. And then for the diagonal, for this one, let's put plus 45, and this one, minus 45. Okay, yep, just like this. So we have the Euler, and then over here, let's just use both the rotation and the position. So let's construct a new local transform. For the position is the world position. For the rotation, for this one, this component, the local transform, that one actually takes in radians, not Euler angles. So let's convert this Euler into radians. Let's use quaternion, rotate on the z-axis, rotate by the Euler z, multiplied by math to radians. Something like this, and finally the scale, we want normal scale, so 1f. Okay, yep, just like this. So we cycle through all the lines in our array, we check all of them. If we have winner, if so, then yep, we're going to spawn it on the center grid position, and we're going to rotate it based on horizontal, vertical, or diagonal. So yep, let's test and let's see. Okay, here we are. Let's try winning horizontally. So let's put it down the middle. So down, down, now click. And if there you go, it does work. Now let's try winning vertically, and let's try winning with this one down here. So let's put an O in there, another one there, and another one. And if there you go, it does work. Finally, let's make a diagonal win. So put that one, and that one. And if there you go, it does work. All right, awesome. So here we have our nice win condition. We can make matches of our symbols in any direction, in any position, and the whole thing works. So if that's awesome, now of course let's handle a proper game over screen, something that says you win or you lose. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a GameOverUI to show up when the game ends. Okay, so let's build our GameOverUI. Let's go inside our canvas, create a new empty game object for the GameOverUI. Then let's stretch to occupy the whole thing. Okay, and now inside of it, let's create a brand new UI. Let's make a text called the result text mesh. And here, since I'm like you win, let's put it with a size of 0, 0, then down the center, down the middle, no wrapping. For the font size, pretty big, some like 70, put it in bold. Okay, like that. Then let's make a background. So let's create a new UI image for the background. Let's drag it above that one so it shows up behind and put it in black and make it a little bit wider like this. Then grab both of them, put them over there on the corner, something like that. Okay, great. Now let's make the script to run this, the GameOverUI. So let's create a new regular mono behavior script, the GameOverUI. Let's wait for it to compile. Let's attach and open. Okay, so now here we're going to need a few things. We're going to need a reference to the text mesh object, also a win caller and a lose caller. So a serialized field, private of type text mesh pro UGUI. It's this one. This is the one in the world, this is the one the UI. So we want the UI. That's the result text mesh. Then let's have another field for a caller for the win caller and another one for the lose caller. Okay, yep, these two. Let's save it. Here in the editor, let's assign it. So let's drag the result text mesh. Then for the win caller, let's select a green color. Also, don't forget over here the alpha, put it on max alpha. And for the lose color, let's put it some kind of an orange red, also max alpha. Okay, great. Now we're here in the script. Let's make some simple show and hide functions. So on show, game object, just set active into true. Then make the hide, and on the hide function, just set active into false. Then make a private void start, and on start, let's begin with this hidden. Okay, so that's great. Now the goal is to show this whenever there's a win, so when the game ends. And for that, we are handling over here on the GameServerSystem, we have the test winner function. Yep, so here we see if we identify a winner. If so, we spawn the visual, rotate it, and so on. So yep. Now, once again, as always, remember what code runs on the clients versus the server. This one is running on the server, but we want to notify the clients that the game has been won by someone. So let's make an RPC to send to those clients. So over here, let's create a new model behavior called the GameWinRPC. Okay, now here, let's go ahead, make this a struct and implement IRPC command. Okay, then for data, since we want to know who won and who lost, let's store a player type for the winning player type. Okay, yep. Then on the test winner function, let's just do that. So go on the entity command buffer, create a new entity. This is going to be the entity for the GameWinRPC entity. And then entity command buffer, let's add a component on the GameWinRPC. And first of all, let's add a new send RPC command request so we can send it. There's no need to set the parameters. We want to send it to all of them. And then another entity command buffer, add a component. This time we want to do a new GameWinRPC and pass in the winning player type. Let's just define, so player type for the winning player type. And the winning one is really just whatever is on one of these. So let's grab one of these positions. So that's going to be the winning player type and just pass in that one into here. All right, yep, so here we are sending the RPC. Then let's go on the game client system, and on this one, let's read for that RPC. So let's just copy this code for the GameWinRPC. Let's grab that one. So replace all of these with the GameWinRPC. So we have this, and when we have win, let's trigger some kind of event. So let's go up here and make that event. So public event handler on GameWin. And we're also going to need to pass in the winning player type. So let's make a class on GameWin event args of type event args, and inside a public player type for the winning player type. So if we have that, and this event is of this type like this, okay? And then down here, let's make that function public void trigger on GameWin, receive a player type for the winning player type. And on this one, on GameWin, let's invoke this event with this and a new one, pass in the winning player type, winning player type. Okay, great. So we have the event. Finally, we can go on our GameOverUI. And over here, let's listen to that event. So dots mono behavior on the GameWin event args. Let's go through the instance on GameWin. Let's listen to this one. So rename this dots events mono behavior. So we have this, and over here, let's show, and let's also update that one. So on the result text mesh, we're going to set the text to either you win or you lose. And we win or lose based on the data inside this event args, the winning player type, and we have to make sure that it matches the one that is on the local one. So we're going to have to do pretty much the same thing we did over here on the PlayerUI. Over here, we grab the client data and we use it, so let's do the same thing. Over here, let's just paste that. So we go through the client world, we grab the entity manager, then grab the singleton of type game client data, and then we can check if this one, if the local player type does match the winning player type. If so, then yep, you win, and let's do the result text mesh.color, the win color. And if not, then let's put it with the lose color and say you lose. All right, yep, just like this, that should do it. So essentially over here, the game server system, this one tests for a winner, and when it finds a winner, it sends an RPC to all the clients. So it sends an RPC and tells who is the winning player. Then the game client system, this one listens to that RPC, it listens to that and invokes a normal C# event. Send here, trigger the on-game win, pass in the GameWinRPC, go into value, and pass in the winning player type. Then over here on the UI, on this one, we listen to that normal C# event, and then we update the text depending on who won that game. So yep, let's save all of our files and let's test. Okay, so here we are, we have crosses up here, circles down here, so let's try to win with the crosses. So now as I click, yep, there you go, you win, and on this side, you lose. So yep, that worked great. Let's do the reverse. So let's try to win on the client. So over here on the client displaying crosses, so let's try to win on the client, go there, there, and if there you go, you win down here, you'll lose up here. So yep, everything works, we've got a nice game over UI, and it shows who won and who lost depending on what is the local player type. Alright, awesome! Hello and welcome, I'm your code monkey. In this lecture, we're going to create the rematch logic so we can restart the game after a win. Okay, so like this, the GameOverUI is working, so if one of them wins, yep, there you go, you win, detects a win, and it shows a you win text. So that's great. Now let's handle a rematch button so we can restart the game without having to stop and start playing again. So first, let's go inside the canvas, inside the GameOverUI, and let's construct a new UI. Let's make a new button for the rematch button. Then let's put the button in black. Let's stretch it out quite a bit, something like this. Then inside for text, let's say rematch. Let's put this in white, put it in bold, and increase the size by quite a bit. Okay, there's our button. Let's just push it down there so it doesn't block the thing. Okay, we have our button. Now let's go on the GameOverUI to add a reference. So up here, let's add another serialized field of type button, and it's this one inside UnityEngine.ui for the rematch button. Okay, let's save. Then here in the editor, let's drag the reference. So yep, just drag that button. All right. So now over here, let's do a private void awake. And on awake, let's go on the rematch button. On the on click, let's attach a listener onto it. And okay, so now here we want to restart the game. We want to do a rematch. But once again, always remember what code runs on the server versus the client. The server is the only one with authority to restart the game. But over here, the UI, this one is running on the client. So let's fire off an RPC to tell the server that we want to do a rematch. So first, let's actually build that RPC. So over here in our project, let's make a brand new RPC for the rematch RPC. Okay, now here, let's make a simple RPC. So just a struct, just IRPC command. We don't need any data, all right? And then over here on the UI, so since we are working in the UI, let's do the same thing down here. So let's grab the entity manager that exists on the client world. Then on that entity manager, let's create a new entity. Let's create an entity with the type of the rematch RPC. And also the type of the send RPC command request. Okay, yep, so this is going to send the RPC to the server. And now we can go over here on the GameServerSystem. On this one, let's listen to that RPC. So over here at the end of our update function, let's listen to it very much like we've been listening to RPCs over here on the client. So let's actually copy this, put it over here. For this, the rematch RPC. Let's listen to this type like this, the rematch RPC. Okay, so we have this, and now the goal here is basically to reset the board so we can play again. So that really means doing a few things. So first is reset the board grid positions. We've got to reset the player types, all of them to none. Then we also need to reset the current playable player type. And then we also need to destroy the visuals. So yep, let's do all of those. So first for the board positions, let's cycle through the entire array. So system API, let's get the singleton RW so we can write to it of the game server data arrays. So let's grab the ref RW, game server data arrays, game server data arrays. So we have this one. Then let's do a for, cycle through int I equals 0, I less than, go inside that one, access the value RO, grab the player type array.length and I++. And yep, then we just go inside this one on this index. So let's access the W on this index and set it equals none. So yep, this is going to reset the entire board. So that's great. Then we want to reset the current playable player type. So that's on the system API. Let's get the singleton RW. This time it's the game server data. So let's grab this one, the game server data, game server data. Grab this one, then go inside value RW for the current one. And for resetting it, for the rules of tic-tac-toe, I'm not sure what are the official rules supposed to be. I'm not sure if it's always meant to restart to just one, or if it's meant to be to who won or who lost. But either way, we can add whatever rules we want in the future. For now, let's keep it simple, just make it always revert back to the cross. Okay, so that handles restarting that one. And finally, the last thing we need is for the visuals. We need to destroy all those visuals. And the visuals, those are the ones that we were spawning up here. So we have to destroy these visuals. And for doing that, basically we can do one of two things. So one, we can either store some kind of list or some kind of array to keep track of all of these elements. So we could make a component, inside put a list, and in that list add all of these as soon as we spawn one. That would work, that would be simple. Or another alternative that might actually be even simpler is we can just tag these components. We can just tag these entities with some kind of tag component, then do a query just for that component and easily destroy all of them. Since we already saw how to work with lists when we made the line arrays and all those, since we did that, let's go with the tag option just so we can see different ways of doing things. So over here in the editor, let's make a new component, a new model behavior script, call it spawned object authoring. And over here, let's make the usual stuff. So let's make a struct spawn object I component data. We have this one. There's no need to put anything. It's really just a tag component. Then a baker class, baker of spawn object authoring. We have this one. Then entity, get the entity of type dynamic, add component on this entity, a new spawn object like this. Okay, so yep, so that attaches the tag component. Over here in the editor, let's just select our prefabs. So we want the circle, the cross, and also the align winner. We also want to destroy that one. So on all of these, let's attach over here our component, the spawn object authoring. So yep, that's it, just a tag component, doesn't need to have any data. And now back over here on the game server system, on the rematch, over here let's just cycle through all of those. So system API, let's do a query refro for our tag component. Let's just grab our spawn object and add with empty access so we can destroy it. So do we for each on this, refro for the spawn object and entity in our query. Okay, yep, so we have these, and now inside this one, let's just go inside and destroy all of these visual entities. So the spawn object entity, destroy all of those. So yep, here we are doing literally everything. So first we reset the entire board, then we reset the playable player type, and then we destroy all the visuals. After doing all of this, then the game will be ready to play again. There's just one more thing we need, which is how we are triggering the rematch over here on the GameOverUI. So we need to make sure that we also hide this one after the game starts over again. So once again, here, when we click, we are telling the server to do something. Then the server resets that, and then the server needs to tell all the clients to hide the GameOverUI so that they can start playing again. So for this, after we do all of that, then let's fire off a rematch event that can hit all the clients. And over here, for this, actually an interesting thing. For sending the RPC to the clients, we can send the exact same RPC. However, when you do, it's actually not necessarily going to work because of one specific thing. So let's try it just to see what the issue might be. Let's go on the entity command buffer. Let's create a new entity. Grab the entity for the rematch RPC entity. We have this one. Then on the entity command buffer, let's add a component on this rematch RPC entity, and let's pass in a new rematch RPC. Then also pass in the new send RPC command request. Okay, yep, like this. And then over here on the game client system, let's listen to that RPC. So let's copy this, paste it again for the rematch RPC. Let's listen to this one like this and see what happens. Then for hiding the UI, let's trigger on game rematch. Let's make that function over here. So make the event, so public event handler on game rematch, and then we have a function to trigger it. So a public void trigger on game rematch, and over here just on game rematch, let's invoke this event with this and event args.empty. Okay, we have the C# event, so now we can go on the GameOverUI. On this one, dots events mono behavior. Let's go in the instance, and on game rematch, let's attach to this one. So dots events mono behavior. And on this one, when this happens, we just want to hide this one. Okay, so yep, so just like this, let us save everything and let's see. Okay, so let's try to win. So on that one. Okay, you win, great. Let's click on rematch. And oh, look at that, it didn't actually work, or rather it became very strange. Note how this one hit the GameOverUI, but the visuals were not destroyed, so we did not get a rematch. And over here to the client, this one did not even hide the game win. So yep, this is the issue. This is why I said this might or might not work. The issue is once again to do with systems ordering. Basically over here on the click button, we are instantiating the rematch RPC. And then the goal is for the game server system, for this one to listen to that RPC, do all of this, and then send an RPC to the clients. And then for the game client, for this one to read that RPC. If that happens, then yep, that's how things should work. But what is happening right here is on the game over win, on this we are sending the RPC, and instead of the RPC actually reaching the server, instead of that, it is actually being intercepted over here by the game client system. So that is why it hit the UI just on the client and didn't actually reach the server, didn't actually do anything. So yep, this is a problem, but thankfully we have two simple solutions. Now, one solution would simply be to define a different RPC type, so we could have just one for the client and one for the server. That would work. Or another, possibly better, easier solution is we can actually reuse the same type, but here on the query for the RPC, we can go ahead, add some more options with all, and let's add the receive RPC command request. Yep, this is the component that we saw quite a while ago. This is the one that contains data on the RPC command. Even if we don't need to know where this RPC came from, even if we know, okay, this came from the server, despite that, we can still include it over here in the query, and that means that this will only match when the RPC is being received and not when it's being sent. So when the GameOverUI, when this one sends an RPC, it will no longer be intercepted by this one, because this one is just waiting for receiving RPCs and not sending RPCs. So yep, like this, our logic should now be working fine, so let's save everything. So yep, here we are, and let's try to win. So go like that, place that one, yep, there you go, you win, you lose, and as I click on rematch, yep, there you go, it did reset on both sides. So yep, and if we try to win on the other side, so let's win down here. So yep, as I click, there you go, you win, you lose, try to rematch on this one. And if there you go, it does work, everything is playable, everything works great. Alright, awesome! Hello and welcome, I'm your Code Monkey. In this lecture, we're going to handle a simple tie condition. Okay, so here in our game, we have the winner working correctly, so if I go and I win, yep, there you go, it works. But the game can also end in a tie. So if now I place over there, yep, there you go, the game ends in a tie, but technically it is still waiting right now for the circles to take an action, but obviously can't take an action, there's no space. So let's handle this scenario properly. This one is actually pretty simple. Basically, we have a tie when the entire board is occupied and we have no winner. So let's go here on the GameServerSystem, let's go down into the test winner function. Okay, so here we go through all the lines and we test if we have a winner. If we do, then yep, that's great. Over here, let's make sure to return, so we end the execution of this function. And then afterwards, after the for each testing all the lines, if none of the lines have winner, then it's over here that we want to check, do we have a tie? If so, then let's just cycle through all of our grid positions. So let's make a simple for, go inside the GameServer.arrays, the player type array dot length, and cycle through all of these. So grab down GameServer.arrays on the player type array on this index. And if this one, if it is none, then that means we have at least one empty spot. So we don't have a tie. So let's define here a bool has tie, default to true. If we find at least one that has none, then has tie becomes false. We have at least one empty position. Over here, let's break out of the for. So if just like this, we check every single grid position inside our grid. If just one of them is none, then we don't have a tie. If none of them are none, then we do have a tie. So if then over here, if we have a tie, if has tie. If so, then we want to handle that tie. And how do we handle it? Once again, always remember how this code over here, this one is running in the server. So when we have a tie, we want to notify the clients. On the server, we don't really need to do anything. The game is already stuck by default since we can't take any actions. So really all we need to do is just tell the clients that we have a tie, so the clients can then have access to the rematch button to start a brand new game. So yep, over here, let's fire off an RPC, so let's define that one. So over here on the RPCs folder, create a new script for the game tie RPC. And yep, here, quite simple, just a struct with IRPC command, and we don't even need any data. So yep, just like this. Then over here, now we can fire off that RPC. So let's go on the empty command buffer. Let's create a new entity. So an entity for the game tie RPC entity. We have this one. Then on the empty command buffer, let's add a component. On the game tie RPC entity, let's make a new game tie RPC. And then let's send that one. So the send RPC command request. Okay, yep, so we are sending an RPC to all the clients. And now just listen to them. So let's go over here on the game client system. And on this one, let's listen to that RPC. So let's just copy this. Now it's the game tie RPC, so let's just copy paste all of these, just like this. Okay, we have this one, and then over here, let's just trigger a C# event. So trigger on game tie. Let's go inside this one, and let's define that one. So over here, the event handler on game tie, and then at the bottom, let's make the function. So public void, trigger on game tie. Just go on game tie. Let's invoke with this and event args.empty. Over here, it's not the rematch, it's on game tie, like this. Okay, yep, so we have the C# event. Now the final thing that we need is just on the GameOverUI. Over here on this one, we want to show it whenever we have a tie. So let's just go on the dots events mono behavior. On the instance on game tie, let's subscribe to this event. So just like this, the dots events mono behavior. And when this one happens, then let's just show. And then for the text itself, let's also say something. So when we have a tie, let's just say tie. And let's also define a tie caller. So let's put tie caller like that. And over here, make another tie caller like this. Yep. Now let's save all of our files. And here in the editor, let's go inside the canvas, inside the GameOverUI. And for the tie caller, let's put it something like a gray, kind of like that, with full alpha. All right, yep, like this, let's test. Okay, so here we are, let's play, and let's make sure we don't win. So let's place down in there, block that one. Now as I click, and if there you go, we have a tie, everything works correctly. Both players know we have a tie, and we can rematch, and now we can play again. All right, awesome. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to keep track of the total score for each player across multiple games. Okay, so since we have a winner, a tie, and a rematch, because that, we should probably also keep track of score. And thanks to everything we've already learned in this course, this is going to be super simple. First of all, let's think of where that data should be stored. The server is the one source of truth, so let's add it over here on the game server data. Let's make two ints, so an int for the player cross score, and an int for the player circle score. So yep, we have these two. Although of course, remember how like this data will only exist on the server, whereas the goal is obviously for the clients themselves to know what the score is. So in order to synchronize them, let's just make these into ghost fields. So ghost field like that and like that. And yep, that's really it. That's how simple it is. Just make it a ghost field. Everything else is already set up. The game server data is already a ghost, so everything's already going to be synchronized. Now all we need to do is let's just go over here on the game server system, and let's check over here we have a win. So it's over here. Let's just check which one is the winner. So let's do a switch on the winning player type. In case the cross player 1, in case the circle player 1, and depending on those, let's go on the game server data and let's write the value. In this case, the cross, so cross plus plus, and this one, the circle plus plus. And if that's really it, that's how simple it is. This lecture is a great example about how after you understand how Netcode for entities works, the whole thing is actually quite straightforward. So for synchronizing any custom data, just make it in a component that is set as a ghost, define a ghost field, and then just modify it on the server, and all the clients will know about it. So now for displaying this, let's go into our UI, so let's save this. And over here, let's go inside the canvas, inside the PlayerUI. Let's create a new UI, and let's make it text, called the cross score text mesh. And let's put it for the width and height both at 0. Let's put some kind of number, put it in bold, put it pretty big, like 100. Let's put it down center, normal, no wrapping. Okay, let's anchor it also on the top corner. And let's put it, for example, this one is the cross score, so let's put it over there on the left side like that. Yep, then let's duplicate it and put it on the right side, and this one is going to be the circle score text mesh. Okay, great. So now let's open up the Player UI. And over here, first of all, let's add those references. So text mesh pro GUI, again, remember, it's the UI. For the cross score text mesh, another one for the circle score text mesh. Yep, let's save. In the editor, let's drag the references. So drag the cross score and drag the circle score, great. Now here, let's make a function to update those. And again, we're going to do the same thing. We're going to basically poll for updates, so we're going to be constantly updating it. Now, technically, if we want to have maximum performance, if so, we should make some kind of event system to make sure that it only updates only when the data actually changes. But since this game is so simple, and since dots events are pretty complex, we can also really just constantly update it. On a game of this scale, either approach really doesn't matter. So let's do that, a private void, update score. And over here, let's grab the entity manager to grab the game server data. So let's actually copy all of this. So we're going to do the same thing. So grab the game server data. Then on the cross score text mesh, let's set the text. Go in the game server data. Let's read the cross score dot toString. And same thing for the circle score text mesh and also circle score like that. So yep, that's it. This is going to grab it. And then just over here on the update, in order to constantly update it, let's constantly call it like that. So yep, that's it. Super simple. Just like this, we have already implemented our score. Let's test. Okay, so here we are playing. Let's go ahead and win. So over there, put there, and there you go. And yep, there you go. It does work. So you win, and yep, the crosses has a score of 1, and the circles has a score of 0. Now let's rematch. Now let's try to win with the circles. So let's put like this, and like this. Yep, there you go. You win, 1-1. Now let's rematch. Let's try to win with the crosses again. And if there you go, 2-1, everything works. So yep, here we have the score synced on both clients and the whole thing updates perfectly. All right, awesome. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add some nice and simple sound effects and music. Okay, so our game is looking nice, a lot of things are already working, so that's all great. But one thing that is obviously lacking right now are sound effects. So let's just add those. Our game is quite simple, so we don't really need anything too complex, meaning we don't need anything with multiple mixers, multiple listeners, and so on. We really just need some super basic audio. And for this, we actually have 2 options. So first of all, one option is to go inside the subscene, and over here, let's construct. Let's go into audio, make a brand new audio source. And if we do, yep, there it is. And we look over here on the anti-baking preview. Yep, there it is, companion game object. So audio is not natively supported by dots right now. So because of that, we basically have 2 options. We can spawn it as normal game objects, so kind of like how we did with the UI. We can do that. Or alternatively, we can actually spawn it as a dots entity and really just use it as a companion game object. Companion game objects are actually perfectly fine. They're going to be obviously less performant than native dots entities, but you can still use them. So all those limitations that dots has right now, you can still use dots code with those. It just won't be as performant as natively. So over here, let's see exactly how that works. Let's use a companion object. So over here, we have our audio source. Let's just name this the place SFX. Then on the inspector, let's go on the authoring mode. And over here, let's assign an audio. So let's use this one, the placing object. Then over here for the settings, we can leave these pretty much on defaults. One important one is over here. Let's make sure we tick play on awake. We're basically going to spawn this in order to spawn the object. Then priority and volume, we can leave all of those. And over here on spatial blend, let's make sure to push it all the way to the left to make this a 2D sound. Okay, so yep, that's it. Super basic. Now let's go ahead and make this a prefab so we can spawn it dynamically. So make it a prefab and delete it from the scene. Now in order to spawn our prefab, we're going to need to add it over here on the entities references. So over here, let's add that one. So first the place SFX prefab game object, then down here, convert that one into an entity. So place SFX prefab entity, and over here, the place SFX prefab entity into that one like that. Let's save it. Then here in the editor, let's drag the place SFX. Okay, great. So now for spawning this, over here on the GameServerSystem, this is where we are handling clicking on the positions. So it's over here, the server, we've got to click on a certain grid position. We swap the current player type, we instantiate the visual and so on. So it's over here that we want to spawn that sound effect. But again, let's remember how this code is running on the server. Obviously, we want to spawn sounds just on the clients. So over here we have two options. Now, one option would be to make that prefab a ghost, and then we could spawn it over here, just like we did in normal visuals. That would automatically spawn it across all the clients, and it would play that sound, so that would work. But also, when making multiplayer games, it is really important to minimize your bandwidth as much as possible. Usually, multiplayer costs are all based on bandwidth, so the fewer bytes you synchronize, usually the better. And in this case, for audio, we don't really need to synchronize an entire prefab alongside position, transform, and so on. All we need is just to know that someone took an action so we can play some audio. So over here, instead of synchronizing an entire prefab, instead of that, we can really just send an RPC and then let the clients themselves spawn local instances of that prefab without any networking at all. That's a great option that will work just the same, but will help minimize bandwidth. When making multiplayer games, always question yourself, do you really need to synchronize all that data, or can you send just a tiny RPC? So yep, let's do that. Over here, we can actually reuse the same RPC, so we can use the clicked on grid position RPC. So let's go ahead and send that one. So on the entity command buffer, let's create a brand new entity. So entity for the clicked on grid position RPC entity. Then on the entity command buffer, let's add a component on this entity right here. We're going to add a new send RPC command request so we can send to it. We don't want any parameters because we want it to go to all the clients. Yep. And then let's also send exactly this same RPC. So let's actually pass in the clicked on grid position RPC. We want this one, which we actually named clicked on grid position RPC. Just use that one, dot value. Yep, like this. So we're going to pass in the exact same data. Okay, so that's great. Now let's just go on the game client system and let's copy our RPC. And this one is going to be the clicked on grid position RPC. So we have this one, just grab this type. Although again, very importantly, is over here, we need to make sure we have this with all the receive RPC command requests. Otherwise, we're going to have the issue that we saw quite a while ago, the issue where the RPC was basically being intercepted by the client and would never reach the server. So over here, let's make sure to add this. Okay, with that, it's great. So this is the clicked on grid position RPC, just like that. And when we do, here, let's just spawn our audio. So go on the entity command buffer. Let's instantiate, go inside the entity's references, which we actually need those. So let's go up here and grab those. So entities references, let's go system API, get the singleton of type entities references. So we have that one, and then down here, we can simply use that one. In this case, we want to spawn the PlaceSFX prefab entity. So yep, just like this. This is going to spawn it, and since we set it to play on awake, it should automatically play that sound. So yep, let's go ahead and save everything. Now let's test. Then here, let's just make sure to drag the reference. Okay, so here we are, and as I take an action, yep, there you go, it did play the sound. And now I take another action on this side. Yep, there you go. Also play the sound. So I can take actions, and anytime I do, yep, there you go. Everything works great. All right, so that's awesome. So here we have the basic sound, and it is working great. Nice. But let's actually also handle one thing. So right now we are playing a bunch of sounds, so that's great. It works. But if we go on the entities hierarchy, and over here, if we look, let's go inside the client world and look at the hierarchy. And yep, look at that. Look at all those place SFX, all of those occupying a ton of space. Basically, we've got a bunch of zombie entities. The entity is spawned, it plays a sound, but does not get cleaned up. Let's make sure to handle this. We really don't want our game to basically end up with a ton of memory just because we are constantly using and spawning new objects. Let's make sure to clean things up. And for this, it's actually pretty simple. We just need a component to store a timer and then to clean it up. So over here, let's make a brand new component, new mono behavior for destroy after time authoring. Then inside this one, let's make a simple component. So destroy. This is a struct. After time, it's an I component data. So we have this one. And inside, we just have a float for a timer. So yep, that's it. Pretty simple. And then up here, we also have a float for a timer and then a class for our baker of destroy after time authoring. We have this baker and then inside entity, get the entity with dynamic, add a component on this entity, a new destroy after time, and pass in the authoring dot timer. Okay, yep, so just like this, close it like that. Okay, now here in the editor, let's go into the object we want to destroy, so the PlaceSFX, and let's set that one, destroy after time authoring, and let's destroy, let's say after 5 seconds. Okay, great. Now let's make a system to handle this. So on our iSystems, create a new entities iSystem, destroy after time system. First of all, this is a client system, so world system filter, run on the client and the thin client, okay? Then over here on the on update, let's just cycle through all of those. So system API, let's do a query, do a ref RW so we can write to it for destroy after time component. Yep. Then let's also add with entity access so we can destroy it. So do a for each on this, for each on the ref RW, destroy after time. So destroy after time. Then the entity, we have these in this query like this. So now let's just count it down. So destroy after time, go inside the value RW, the timer minus equals system API dot time dot delta time. And then if destroy after time, let's read the timer value. If that one is under 0f, if so, then let's destroy it. So let's make an entity command buffer. Let's create a brand new one with allocator.temp. We do this, then at the end, we call playback with state.entityManager. And then over here, if the timer is elapsed, then let's destroy the entity and destroy this entity. Okay, yep, that's it. Just a super basic, super simple component. Count down the timer and destroy the entity. That should do it. Let's save. Now over here, let's take an action, then look in the entity's hierarchy. Okay, so let's take it. There you go. Okay, so now over here, let's look in the hierarchy, make sure we're looking on the client world. Okay, let's take an action. There you go, there's the PlaceSFX. And now after 5 seconds, it should vanish. So after 5, there you go, it is gone. So everything's nice and cleaned up. So we can take a whole bunch of actions, do a whole bunch of things. And when we do, we've got a bunch of PlaceSFX. And after a while, they all get cleaned up one by one. All right, awesome. Now, like I said, this way we are not using ghost objects. So we basically just have a normal local entity. This way, all we're synchronizing is really just an RPC. So because of that, we have very little bandwidth usage. It's just a basic RPC. Then we just handle all the logic of spawning, destroying. All of that is just handled locally without any network connection. So when making multiplayer games, always remember this. If you can avoid synchronizing some things, then that will usually be the best approach. Okay, so that's great. So this is working. Now all we need are to apply that to all the sounds. So here in the project files, here are all the ones that I prepared. So placing object, win, lose, and music. So let's do the win and lose. Let's make the prefabs that are going to be spawned. So PlaceSFX, duplicate this for the win SFX and the lose SFX. Then just swap out the audio resource. So this one is the lose and that one is the win. For these, the settings are all the same. To the audio, play on awake. Great. Now let's make those references over here on the entities references. So make 2 more. So for the win SFX and the lose SFX, and down here, same thing, win and the lose. Then over here, also the win and the lose and the lose and the win. Okay, let's save. Now here in the editor, let's drag those references. So the win and the lose SFX. Okay, great. Now over here on the game client system, on this one, we're already getting the RPC when the game ends. So here we have the game win. All we need to do is just check if the local player is the one that won. So we just need to grab the game client data. So over here on the game win, system API, get the singleton of type game client data. So we grab that one, game client data like that. And then we check if the game win RPC, if we go inside and grab the value, grab the winning player type, if that one matches the game win client data, matches the local player type, if so, then we have a win. And if so, let's go on the entity command buffer. Let's instantiate, go on the entities references and grab, in this case, the win SFX. And if not, then let's go and grab the lose SFX. Okay, that's it. Super simple. We just spawned the entity and that's it. Everything is already handled. It's going to play the sound. It's going to be cleaned up. So let's test. Okay, here we are. Let's go play crosses. Let's try to win with the crosses. This is the one that the sound is enabled. Over here, I muted this one. So as I win with this one, we should be able to see the winning sound. So as I click, and if there you go, there's the win sound effect. And now let's try losing with this one. So let's try winning up there. So place like that, and now place. And if there you go, there's the lose sound effect. Okay, great. So all of our sounds are working. Finally, all we need is just the music. And this one really just needs an audio source that is constantly playing. So that's really basic. Just on the game subscene, let's go ahead. Let's construct a brand new. Let's make it an audio source. Name this the music. And over there on the audio resource, let's just select the music. then maybe put the volume a little bit lower, play on awake, and set the loop. And if that's it, and right away, since the subscene is loaded, we can actually hear the music right away. And if we hit on play, yep, same thing, the music is currently playing, and we can take action, so let's go, like that. We can hear the take action sound effect, and as I win or lose, we can also hear that same sound effect. Alright, yep, so we've added sounds, and we've added some music. Awesome! Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add two Unity tools to our game, Lobby and Relay, as well as talk about some other multiplayer tools. Okay, so yep, our game is basically done. Now for multiplayer, you probably want to implement Lobby and Relay. I have dedicated tutorials on both these tools. Lobby is how you can group players together before the game, and Relay is how you can connect them through the Relay server in order to bypass firewalls and that. By the way, one quick note, these used to be two separate packages in the package manager, so Lobby and then another one for Relay, like this. But yep, as you can see right now, with Unity 6, they are currently marked as deprecated. Now this means they still work, they will still work perfectly fine during the Unity 6 cycle, so technically you can still use the standalone packages for the next 2 years, but they are deprecated, they won't be removed in a future Unity version. So nowadays Unity recommends you use the Multiplayer Services package, and thankfully migrating from those packages to this one is actually extremely simple. All of these are part of what Unity calls Unity Gaming Services. This is a collection of a ton of tools to help you make games, and a lot of tools specifically for multiplayer games. In order to make these work, you need to make sure that your project is created on the dashboard. Now, if in the beginning, when you create the brand new project, if you toggle that checkbox that said Connect to Unity Services, if so, then it should already be set up by default. If not, we can go into Edit, then go into Project Settings, and then over here on the left side, we can go to the Services tab, and if there it is, here you can either create a brand new project, or you can see the one that is already created. Like I said, if in the beginning you already connected, then it should already have this set up. If not, you can just click the button to create a brand new project. Now over here I have implemented Lobby just like I did in my tutorial. I'll literally grab the code from that tutorial and just paste it on here. And of course the project files for this lecture already have this whole thing set up. If you want to see how the whole thing was built, you can go watch this tutorial step by step. Over here I have the code imported pretty much from that tutorial. So here we've got all kinds of code for doing authentication, refreshing the lobby list, doing the lobby heartbeat, polling for some lobby, getting the lobby, checking if it's the host, getting the player, creating a brand new lobby, refreshing the lobby list, and a bunch more things. So over here, let's test. So first of all, we need to authenticate, and usually this process is automated. The reason why I made this manual is so we can input actually a different player name. Now this is important because if we authenticate with the exact same name, then we're going to have issues. So just for testing, we should authenticate with different names. And if there it is, it connects, so here we can see the lobby list. And right away on either of these, we've got a button over here to create a brand new lobby. So we can input some kind of name, so my lobby, something like that. We can make it public or private, so let's do it just like this. Let's go ahead and create. And if there it is, there's the lobby and we are inside the lobby. And now on this other player, I can press the button to refresh or just wait a little bit. And if there it is, I can see the lobby right there. Now I can click to join, and as I do, as this lobby host, as this one notices that 2 people have joined the lobby, when it sees that, then it's going to automatically start the game and then everything else works. So over here I join, there you go, this one sees 2, this one after a while also sees 2, and down there in logs we can see it's doing a whole bunch of stuff, then it's loading the final game, and yep, here it is, everything is working perfectly fine. Now here we can play, and yep, the whole game plays exactly the same as always. So yep, great. Basically the logic here is we create a lobby, so we pass in some kind of lobby name, the max players which is fixed by this game, then make it public or private, and the game mode, that is just something that I used in that tutorial that I made. It's not used in this game, but like I said, I literally just copied the exact same package from that tutorial. So yep, then here it creates the lobby options and contacts the lobby service in order to create the brand new lobby. And that's it, just creates it. Then on the other side, that one refreshes the lobby list. It finds all the lobbies and then just uses a function in order to join that lobby. So yep, that's a lobby. That's a really great tool for grouping players together before starting the game. And then the other really important tool is Relay. So far throughout this game, we've been using over here the play mode tools. So we set up one as client and server and the other one as just a client, and doing so it automatically connects. But the way that it connects is literally just locally. Actually over here on the play mode tools we can see the connection that it's connecting to. By default it is connecting to 127.0.0.1. This is literally the local host, it's a local PC. If you wanted, you could manually allow the user to select the IP of the server they want to connect to, and then you would set up the connection to go straight towards that external IP. However, in doing so, you need to make sure that the server can actually be connected to. If the server is a player host, then they need to make sure they have their ports open on their firewall. If not, then it will not connect. This is a very common issue with multiplayer games that are player hosted, and that is exactly why the relay exists. The relay is basically just a third-party server that is easily accessible from the internet. All the players from anywhere in the world can easily access this server. this server has all the ports open so it can listen to connections. Since the server is on the public internet, because that, all the players can connect to it. And doing so, the relay acts literally like a relay, meaning it just passes messages back and forth. So the players might not be able to connect directly between one another, but since they can connect to the relay, the player sends a message to the relay relays that message to the other player, and so on, and that's how they all connect to each other. Now, naturally, obviously, this leads to a higher ping since the connection has to go through the relay, but the huge benefit is it means it has no problems connecting. You don't have to ask your players to do port forwarding or disable their firewall. You just implement relay and all the players will be able to connect to each other without issues just by going through the relay server. So if you're not using a dedicated server, you really should implement relay in your games. That will avoid a lot of frustration with players. It will make it so that any players anywhere behind firewalls, NAT, or anything, any of those won't be able to connect to any other players without any issues. So over here, I have also implemented relay. Again, like I said, literally the same thing, so I pretty much just copy-paste the exact same code that I did in this tutorial. However, in this case, actually a bunch of things had to be modified in order to make it work with Netcode for entities. Over here for this tutorial that I did was mainly based on Netcode for GameObjects, so I had to modify a few things. And actually, this was a really tricky one that actually took quite a lot of research because for some reason Unity doesn't have any documentation specifically on implementing relay with Netcode for entities. So the main way that I managed to figure out how the whole thing works was by going through the NT component system samples. By going through this one, the hello netcode containing the basics for the relay support. Over here on this sample, I read through this whole thing in order to figure out how to make it work. So basically on the lobby, that one is still perfectly normal. The lobby is just an HTTP connection, so there's really nothing clever to do there. Nothing different between Netcode for GameObjects and Netcode for entities. Then the lobby fires off this event, which this script over here listens to. Then when this one listens, here it has a function to create the relay, and here is that function. So it contacts the relay service in order to create an allocation. Then it gets the join code along with that allocation ID. Then it uses that in order to generate the relay server data. And now here's a really important part. In Netcode for entities, you need to create the relay server data and the relay client data. You need to create both these. So you allocate the relay, then you create this one, and then you also have to join that relay manually, and then you also get that relay server data. So this is the one step that is not required if you're using Netcode for GameObjects, but with Netcode for entities you have to do it like this. So you do this, and then through the lobby tell the relay join code to all the other clients, and then over here call the function to start the host. So then this function is all the way up here. Like I said, I took this code from this sample. This is how I learned how this whole thing worked. Inside the sample, I grabbed this script over here. So basically the relay requires a custom script, something that implements this interface. This one takes in a relay server data and relay client data. It takes in both these. Then over here has a function to create the client driver. And this one also has an important thing. I initially made it calling this function. And just like this, with register client driver, for some reason making a build wasn't working. It was saying that IPC connections are not available. So in order to make it work on a normal Windows build, for that I had to use this function, register the client with UDP. So yep, that's one modification I had to make. And then back here on the startHost function, again, like I said, create a brand new driver constructor, then go through the client server bootstrap in order to manually create the server world and the client world. So another thing that I should mention is since the game now no longer connects automatically, because of that I also modified this script. So this script that we created in the very beginning of the course, by this we were setting the auto connect port and automatically connecting. But right now we only want to connect when the lobby actually connects two players together. So we don't want to connect automatically as soon as the game starts. So because of that, I disabled the auto connect feature. And when we do, then these servers are no longer going to create automatically. So we have to do it like this. So create the server world and the client world. Again, we are here starting the host. So that is why we create both the server and the client. So yep, we do that. Then we dispose of any previous game worlds. We define the default world as the server world. And then we load the game scene in order to load the final scene. Then over here, I have two pieces of code. So this one over here that is commented. This is how you connect to a specific IP. So you define a port, then you do a query to look for a network stream driver, and on there you call listen. You listen on any IPv4 endpoint, listen with this port, with the port that you assigned. Importantly, you do this listen over here on the server world, and then you go inside the client world, and on there you also grab the network stream driver, but this time instead of calling listen, you call connect, and you pass in the connect network endpoint, which since this one is the host, you want to connect to itself, so that is why over here it is connecting to the network endpoint loopback IP. So that is that one, 127.0.0.1, that's your local host. Since this is running the host, we start off the server and we start off the client and connect to the local host. Like I said, this code over here is if you do not want to use relay, if you want to connect directly to a certain IP, but if you do want relay, like over here we do, if so, then this is the code you want to use. So first we construct an entity using this component, the network stream request listen. This one basically tells it to listen to something, and over here we want to listen to any connection, so we use the endpoint as any IPv4. And again, importantly, this code runs on the server world. And then we have some other code running on the client world. This one is the network stream request connect. And on this one, we're going to connect to the relay client data.endpoint. So you have this relay client data. Again, remember that's one that we got over here when we created the relay. We created the relay server data and relay client data. So you grab both these and then we use it over here. So first of all, we use it over here for creating the constructor and then down here for connecting this one. So yep, that is how we start the host. All of this code runs. It is going to create the URLs and set up the entire connections. So over here, connecting by IP and connecting through the relay. And then on the other side, we have the start client. So once again, the whole thing starts up here. When the lobby says it's time to start the game, if we are not the host, then we're going to join the relay and pass in the relay join code. So that is one that over here, when we create the relay, we call this function in order to set the relay join code. This one is going to update the lobby, so it is going to set the lobby data and pass in this relay join code. That is how all the clients get access to the same relay join code. Then all the clients listen to that join code and they use this. Then they go through the relay service, they call the join allocation async, and through there they grab the relay client data and then call this start client function. So yep, here it is. Once again, using the same relay driver constructor, except over here for the server, we just do a brand new empty one. We're not going to use that. Then we go ahead and we just create the client world, because again, on this one, it's just a client, it is not server. Then once again, we clean up the old worlds, we assign the default world, then we load the target game scene, and once again, here we have the two pieces of code. So this one connecting directly to an IP, and this one through the relay. So for the IP, we create a new network endpoint, we pass in a certain IP and a certain port. We do that, then use the network stream driver and use the connect function in order to connect to it. And yep, that's how you connect to a certain IP. But here we want to use relay, we don't want to connect directly, so we do this down here. So we first create a new entity with a network stream request connect. So we request to connect somewhere, and we just try to connect to relay client data.endpoint. Once again, the relay client data, this is the one that down here on the join relay, we join the relay allocation, we create it from there, and yep, this is the data that contains the IP of the relay that we're going to connect to. So that handles it, and after that, everything is working. So over here, we are loading the final scene, the game scene. So when this happens, after all this, both players are going to be connected through the relay and both of them playing the exact same game. So here we are with both of them. On this one, let's just give it a different name. So like this, authenticate, and on this one, then over here, let's create a new lobby, create a brand new one. There it is. On this one, refresh, let's join. And once again, when join Sue, over there we can see, yep, all those logs, those are all related to the relay. It is all connecting to relay and doing a bunch of things. And yep, after the whole thing works, that whole thing happens in the background. So it selects the relay server, it connects the relay, sets up the connection, and yep, here it is. Now everything works perfectly fine. All right, awesome. By the way, like I said, on those tutorials, those were made using the old deprecated packages. Whereas over here on this code, I'm using the new multiplayer services. But thankfully, there's pretty much no difference between those. Pretty much all the code is exactly the same. There's an official tutorial for how to migrate, and literally the whole thing is literally just remove a package, install a new package, and that's it. So over here on this one, that is basically what I did. There were only a few tiny things that I had to change. So one thing was over here on the lobby manager. There were some of these functions that were being called through something called lobbies. That's what it used to be named, and now that no longer exists. Now the whole thing is just called lobby service. So replace any kind of lobbies with lobby service and the whole thing works. And the other thing that I had to change was also on here on setting up the relay. So here for creating the relay server data, previously you would do something like new relay server data, then pass in the relay. You do that, but nowadays that no longer works in this package. So nowadays the correct way is like this. So basically you grab the allocation, and through that allocation you have an extension method. And through that extension method, you just pass in the connection type. And like that, it creates the relay server data and it works perfectly. So you have just a few minor things, but for the most part, everything works great. Also, one important thing about these tools that you might be wondering is what about pricing? And thankfully, these tools are either completely free or extremely cheap. So you can find the pricing page for all of the Unity Gaming Services tools. And over here under multiplayer, we can see a bunch of those. So for example, we can see the lobby. And lobby over here is handled by bandwidth. So basically the lobby data that you synchronize across all the players. And lobby data usually is very tiny, and it's not something that you are synchronizing 60 times per second. So over here, the 10 gigabytes that you have per month, this is on the free tier, so you don't pay anything for that. That is a generally huge amount. So unless your game is a mega hit, you are probably not going to pay 1 cent for lobby. And same thing over here for Relay. Relay is paid based on concurrent users. And your first 50 average monthly concurrent users, those first 50 are completely free. Once again, that's a huge amount. Most indie games do not get to 50 concurrent users. So for most games, Relay is going to be completely free. For context, my latest game, Dinky Guardians, does have a multiplayer mode. The game did quite alright, and still only managed to hit a 26-player concurrent users. Now in my case, I think this data isn't 100% accurate because I did have to pay about 50 cents, so technically I did go above the limits. But like I said, for a game that did quite well, I only had to pay about 50 cents. So if these tools are really great, really awesome, I highly recommend you use them just to make your games easy to play for your players. And these limits, these are pretty generous. So chances are you're probably not going to have to pay anything, and if you do, the whole thing is pretty cheap afterwards. So if those are the two main multiplayer tools that I would recommend, but Unity has a bunch more if you want to expand upon your game. I covered a bunch of them in this video. So first of all, when it comes to synchronizing data, you've got Netcode for game objects or Netcode for entities. Those are the two main ones. Then you've got Relay to connect players behind firewalls and NAT, and you also got Lobby to group players together, so the two that we have already seen. Then if you want to make dedicated servers, you've got Game Server Hosting. This allows you to automatically spin up a fleet of servers on the cloud. Then you can spawn more or fewer servers depending on demand. So if you want to make a super complex game, then this is the tool you want to use. For example, Apex Legends uses this to manage their backend. Then if you do use Game Server Hosting, Matchmaker is a great way to match players together based on rules. Those rules can obviously be based on player skill, but also based on pretty much anything you want. Can be based on location, map, team size, and a bunch more. Then if you want to have your players talk to one another, either through voice or text, then you have VVox. This lets you easily handle those. And if you implement those, you might also want to implement Safe Voice. This is a tool that helps you identify voice toxicity, which in multiplayer games, toxicity is something that is really important. Toxic players just make the game worse for literally everyone, so this is something that is very important if you want to make games where anonymous people play with one another. All of these tools are basically dependent on authentication. This is how each user can have a unique ID. And if this is also something that we implement in our game, then there's also the Friends tool. This one lets you set up friends lists, and importantly, it's cross-platform. So the same friends list can work across PC, consoles, mobile, literally anything. Unity also has a leaderboard tool, so yep, if you want to implement online scores for your players to complete, you can go with that one. And then you have analytics. This is really not related to multiplayer, this is really just something for literally any kind of game. You can save any kind of data to help you as a developer make your game the best it can be. So as you can see, a bunch of tools that do a bunch of things to help you make multiplayer games. Also, speaking of all of these multiplayer tools, Unity has something called the Multiplayer Center. You just go up here into Window, then Multiplayer, and yep, the Multiplayer Center. It pops out this window, and this is a really nice way to see all of the multiplayer tools that Unity has and how they interact with one another. Over here on the left side, you can select the genre of the game that you want to make. Like, let's say we want to make some kind of shooter game, then the number of players per session. Let's say we want a shooter game, something with about 16 players. And yep, then here's some more details. So is the gameplay meant to be fast or slow? Is cheating, modding, prevention, is that important or not so? What about cost, netcode architecture, and so on? So you can play around all these settings, and depending on what you select here, over here it suggests a bunch of different Unity tools. So for example in this game, so a shooter with 16 players, with fast-paced multiplayer game, where cheating is very important, so something that would be like fast-paced competitive. In terms of cost, something that favors the best player experience. In terms of netcode architecture, something that is client-server. So essentially over here we have defined, let's say, competitive shooter, so something like Call of Duty, Battlefield, and so on. So these would be pretty much the settings, except maybe a little bit more players. So yep, by selecting all of these, then over here we can see the recommended things. So if you were to make a game kind of like that, kind of like Call of Duty, Battlefield, and so on, if so, then they recommend for netcode using netcode for entities. This supports server authority and client-side prediction, very important for these kinds of games. It supports 64-player games, so just like that. It offers good performance and is preferred if cheating prevention is important, and tends to be better for fast-paced games. So it recommends both installing netcode for entities for synchronizing multiplayer, as well as graphics for rendering all the visuals. So yep, that's the netcode solution. For the hosting model, they recommend a dedicated server. So this means that the dedicated server has authority over the game logic. This is the model you want to use if you have a high number of players and lots of data being synchronized, as well as obviously cheating prevention. Then for some more, recommend multiplayer packages, VVox for voice and text chat, multiplayer services for using lobby, matchmaking, and so on. Then they also recommend widgets, I'm going to talk about these in a little bit, and multiplayer play mode for easily setting up everything. And then technically we could also install dedicated servers in order to streamline dedicated server builds, and multiplayer tools, although this one says incompatible. I believe this one is only for netcode for game objects. So yep, as you can see here, you can define all of the properties for your game, and then over here it automatically suggests a bunch of things. Then here they've got nice toggles, and once you click on install packages, it is going to install all of these. So yep, this tool is really nice, really useful for making all kinds of games. Literally just select whatever you want, like let's say simulation, slow, not as important, with only about, let's say, 2 players. So something like a small scale co-op game, and yep, it recommends netcode for game objects with distributed authority and a bunch more stuff. So if you don't know out of all of these tools which ones you should use, if so, then using this tool, this is really great for telling you exactly what you should use and why you should use it. Then like I said, there's the multiplayer widget, that one is also quite interesting. For that, you go first on the package manager, and then over here, look for the multiplayer widgets. Yep, this one over here. We can go ahead and install this one. And like the name implies, this one provides a set of widgets that help implementing all the various services. So basically, if you want to very quickly prototype a multiplayer game, you can use this to get a bunch of stuff up and running very quickly. If you then go onto game object, then multiplayer widgets, and then yep, here we have a whole ton of widgets. So for example, one for creating a session, for joining a session by code, getting the session list and so on, for showing the player list, showing the session code, and a bunch more. So you go ahead and as you click to create one of these, if there you go, it automatically goes onto the canvas and creates a predefined widget. So in this case, just something to create a brand new session. So when you do, then just adds this script, which adds a bunch of things that you can hook onto, so you can very easily quickly get started. Now in this game, I didn't use the widgets, just because I already had the lobby code that I made in a previous tutorial. So in this case, I really just reused the same code that I made myself previously. But if I didn't have that, then over here using these widgets would be a great way to quickly get started. Then Unity is also currently working on the concept of what exactly is a session. This is something that is part of the Multiplayer Services package. Now for this, I haven't yet quite looked much into what is the concept of a session, but it seems quite interesting. It's basically yet another way that makes it much easier to get started making multiplayer games. You can create a session, and then through that, you can easily integrate with all of these various tools. But in general, the main ones you really want are Lobby and Relay. That way you can group players together in Lobby, they can join themselves together, and through Relay they can connect to one another even if they have issues with firewalls and that. The whole thing bypasses it. So you can do that, implement those two, then your players can join together, play together, and the whole thing works perfectly. Alright, awesome! Hello and welcome, I'm your Code Monkey. In this lecture, we're going to look at a bunch of things that I did to polish the game. Now, whenever you work on some game, at some point you should definitely take some time to do some polish. Polish is a really important part of any kind of game. It is really what separates good games from great games. Polish is really all the tiny things that you add that really take your game and take it to the next level. And for this part, I used a handful of third-party assets to polish the game. Although sadly, I actually wasn't able to use most of the assets that I normally use for polish. The reason is because some of those do not support dots. For example, my favorite polish asset is Feel. This one is really awesome. I made an asset review on this one. I use this one pretty much all the time I want to polish some game. It is really great, but it only works with game objects. So since over here we use dot entities to render our player objects, because of that we can't really use this. At least we can't use it for the actual in-game things. Another awesome one that I like to use is this one, the all-in-one sprite shader. I also made a nice asset review on this one. This one is also really great for adding all kinds of effects to your sprites. In this game, we are using sprites, or rather, we are using quad meshes, but sadly, the renderer, the shader that this asset uses, that one is not supported by entities rendering. So this is another asset that I normally use, but sadly I wasn't able to use it because we are rendering our objects using entities rendering. One tool that I did use and that is really awesome is this one, the text animator. This one lets you very easily animate your text, so it's one of those really tiny things that make the game feel much more alive. And then for some visuals, I also use some things from this UI pack. Now, because these are third-party tools, because that means I cannot include them in the project files. I don't have the rights to distribute them. So the final project files you can download are the ones right before this stage, the ones that have Relay and Lobby implemented, but none of these polish effects, because again, I cannot distribute these project files. So here is what I made with all of those. So in the background, I've got a nice little background effect. Then over there, I use some of those UI elements to polish the UI a little bit more. Then for the objects, like I said, I cannot use Feel. That is what I would normally use in order to polish the placing of objects. As you can see, there's a little shine and there's a nice little animation. Usually I would do that using Feel, but over here that was not possible. So I had to figure out a different way to do it. And the way I did it is actually quite clever. I basically defined a symbol component. Inside that symbol component, I just have a float timer. And then I defined a normal mono behavior. It has the singleton pattern and then just expose a bunch of animation curves. Here in the editor, here is a game object, so just a normal game object. And on this one, yep, over there we can see the curves. So I made a curve for the spawn object X and the spawn object Y, meaning the scale. And then another one for the intensity of the glow color. So these are animation curves. In case you don't know, this is a normal Unity feature. It is really awesome. Basically allows you to define curves with any kind of shape you want. You can add all kinds of points. So for example, for making animations through code, this is super helpful. And that's exactly how I use it. So basically define a curve for how to scale the object on the x-axis and in the y-axis. So over there, for example, you can see the curve on the y-axis. First of all, it expands, then despands, and then goes back into normal. And on the x-axis, takes a while, and then expands on the x. So the whole thing makes a nice squash and stretch effect. Over here, as I place an object, you can see what happens. And there I go, and as I click, yep, there you go, and look at that, basically squashes over there on the y and then on the x. So again, since I wasn't able to use that asset, since that one is based on game objects, because that, I just made this system over here. This one works with normal mono behaviors. And then I have a nice normal dots animation system. And this one really just grabs that one, grabs the post-transform matrix so I can deform the actual quad object, then just checks the timer and uses that timer basically to evaluate those curves and uses those in order to scale that object. So that is how I do the scaling based on those animation curves, which again, by using those, then we can use it inside dots. And the second thing is for that little glow right there. So for that one, in terms of the code, I just use a different curve. And for the different curve over here, we can see it starts off at 1, then goes back down to 0. And for that curve, it is really just applying the alpha to a color, and that color has some intensity. So it basically starts off with high intensity and then becomes 0. And for modifying that, once again, using entities rendering, over here we're using the URP material property based color. So we're using this component. Then here in the project files on these prefabs, so for example, we go inside the cross component. And over here on this one, if we go inside, if we look, yep, here on the quad, so this one, I added that one, so the URP material property, yep, and I added that component, the authoring component, so we can animate things. And this one, basically, I had to split it 2 ways, because again, that asset that I normally use for all of these sprite effects, that one does not support the dots render, so that is why I had to do it the manual way. So basically there's this one, this is the manual cross. So this one is really just going to have the squash and stretch effect. It is not going to animate the color, nope. And then I duplicated that one, and this one now uses a different material. It basically has the exact same shape, except instead of using the cross texture, it uses a cross glow texture. So literally the exact same shape, but just printed in full white. And then over here on this one, I just went ahead, I applied some emission so we get some nice glow. So there you go, it starts off with an intensity of 2. And then through code, basically what that is modifying is over here going on to base map on this color. So by modifying over here the URP material property, by modifying this component, it ends up modifying this one. So if we see, so if we drag, let's say, go inside of our game scene, and then over here, let's just open the subscene, and I'm going to drag, let's say, a cross on there. So if there you go, there's a cross in there, and you can see there's a nice glow. So basically, through code, we are animating this. So going inside this one, and then over there on the authoring component, we're basically taking this one and bring the alpha down to 0. So if there you go, as you can see, that one stays quite a bit on the alpha, quite a bit glow, and then stops glowing. So if we put it all together, here's the result, click, and there you go. There's a nice little glow, nice little squash and stretch effect. So the whole thing looks nice and polished and looks much better as opposed to just spawning it directly. So yep, that's awesome. Then the other thing that I also modified was the text. So as I go and I win, if there you go, over there, the you win text, you can see that one has a nice little wiggly lines. So that is the little animation that is handled through the text animator. Since the UI is using normal game objects, and pretty much any asset would work with this UI. So for this one, it is just, let's go inside the canvas, look inside the PlayerUI, and here we've got the result text mesh. Actually, it's on the GameOverUI, so here it is, the result text mesh. And for this one, the only component is really just, this one has the text mesh pro, and over here just add the text animated component, and then over here on the behaviors, just add the wiggle behavior, and then set some properties for it. Set it like this, 0.3 and 10, and yep, the whole thing has a nice little wiggle, so something very subtle, but it does look quite a bit nicer. Then I add this same thing over there on the connecting UI. So on this one, same thing, it is also nice and animated. So again, small thing, looks great. And then on the rematch button, on this one, also made it to change to a different visual, just to signify that it is being clickable. So yep, a bunch of nice tiny effects that make the game feel quite a bit more alive, quite a bit more interesting. Then the other thing that I did was simply, like I mentioned quite a while ago in the beginning of this course, how for performance purposes, over here I told you to disable burst. So go ahead and disable that one so it's faster to iterate. But before you make the final build, go ahead and enable the compilation. And actually, I don't think you manually need to enable this. If you make a build, it is always going to have burst enabled by default. But if you do, you might actually see some compiler errors. That is because if you use burst inside a function, if so, then over here you cannot access any managed data. So for example, you cannot access any managed model behaviors, you cannot do any debug logs and so on. You cannot use objects if you use burst. So what I did in this lecture was also just going through all these scripts and either removing where we access some managed objects, removing that when it was possible, like for example over here it is not possible. So when it isn't possible, really just disabling burst on this function, meaning it won't run as fast, but again, this game is so simple that burst isn't really all that necessary. So really just removing burst in order to make sure that this code compiles, and then I can make a nice final build. So yep, these are all the nice tiny things that I made to polish the game. Just go ahead, everything is nice and animated. We've got a bunch of nice effects, so everything looks really good. So we can click to place objects, they look really nice. We can place all kinds of things. One wins, the other one loses, and everything looks really nice. All right, awesome. Hello and welcome, I'm your Code Monkey, In this lecture, we're going to take a look at our final polished game. Alright, so let's look at the final game. So right away we start off on the authentication window, so we can authenticate with different names so we can test on the same PC. And right away we go into the lobby scene. So this is where we can create lobbies to join our players together. So over here on this one I can create a lobby, then on this one down here I can refresh the lobby. There it is, I can click to join it, and as soon as this one joins, we can see it automatically starts loading the final game. In the background, the whole thing is using relay, so it is connecting to the relay and setting up the connection between the two players, meaning that this game is playable even if both players are behind some firewalls. And here we are in the final game. Here up top we can see which is the current playable player type, so right now it's the crosses, but this player over here is actually playing the circles, so it's this one down here, this is the one playing crosses. So this one goes ahead, clicks, and there you go, it spawns an object and gets synchronized across the network. Now it's this one, I can take an action, then take another action, then keep going on and on until, there you go, here we have a winner and here we have a loser. So everything is synchronized, all of the player actions, all of the player positions, the player result. We are synchronized the current player type, the local player type, and also over here the actual scores for the entire game. And of course we have a rematch function, that one also works. So we can rematch, it clears the entire board, and now we can start playing again, so we can take actions all over the place, and everything works great. So in terms of multiplayer, here we are using Netcode for entities to sync all of our gameplay data. This is Unity's networking tool stack meant for more complex, data-heavy, fast-paced games. Here we'll learn how to start and set up the connection, first by using the auto connection feature, and then by using the manual connection. We do that, then we'll learn how to send and receive RPCs, so we are using over here in order to send in the player type. We have an RPC for when we click on a certain grid position. Then we also learn about the concept of in-game and the concept of ghosts. This is how we can synchronize these objects and take actions all over the place. We also learn how to synchronize data using ghost fields, specifically over here for synchronizing the score. We just had the ghost field attribute and automatically synchronized a bunch of data. So we did all of that in order to make the final game work. And then of course, we also implemented lobby and relay in order to make everything work perfectly. So we used all those tools, all of that, in order to make a nice, simple multiplayer game from scratch. So here it is. I really hope you managed to understand how to use Netcode for entities. With this knowledge, you can now take advantage of this tool stack and make some really awesome, cool, complex multiplayer games. Now, if you're following along with the premium version, then I highly recommend you now go through the companion package once again, go through all the quizzes and all the FAQs to see if you can still get them all right. If you can, awesome, that is proof that you have truly learned by watching everything in this course. If not, if you got some wrong, then maybe go rewatch the lecture to make sure you're truly learning. Remember how you only truly learn by doing, so take some time to actively test your knowledge and ensure you have really learned all the contents in this entire course. Hello and welcome, I'm your Code Monkey, and congratulations on going through this entire course. I really hope you learned a lot. I hope by now you feel capable of taking the knowledge you gained in this course and apply it to making your own original multiplayer games. Here you'll learn all about Netcode for entities. Now this sounds a little bit tricky at first, but by going through this course, hopefully you now saw how it's actually not that complicated. RPCs are pretty easy to send and receive, ghosts are pretty easy, and marking some custom data as a ghost field is also pretty straightforward. This tool, Netcode for entities, this is super powerful. It's what you want to use if you want to make fast-paced, complex multiplayer games. So games like Call of Duty, Apex Legends, Rocket League, League of Legends, Mortal Kombat, and many others. These are the games for which this tool is absolutely perfect for. And of course, all those games, the difference between those is really just all about data. Multiplayer games are all about data, just what data you synchronize. So by learning how to use Netcode for entities in this course, you basically can take this knowledge now and apply it and be able to make pretty much any of these games. Now if you found this free course helpful, you can now go ahead and pick up the premium version. If just a tiny percentage of people pick up the paid version, I can keep making free courses. And if you do, then now go ahead and take the time to go through all the quizzes and FAQs. That way you really test your knowledge to verify if you did actually learn all the contents in this course. So if you can afford it, that's awesome. Check it out with the link in the description. But if you can't afford it, then that's fine. I hope you learned a ton from this free course, and I hope it helps you a lot on your game dev journey. Just go ahead and like the video if you haven't already. Then if you want to continue learning, check out my other courses. My C# course is really great for developers of any skill set. It covers everything from the absolute basics to really advanced topics. Or for more game-based courses, my turn-based strategy course is an excellent intermediate course on making a really cool game. Or of course my dots course, if you haven't gone through that one right now, then definitely go ahead and do it. It teaches you how to use all about dots, which can make your code run literally 200 times faster. Or my ultimate Unity overview course, that one covers basically all the tools and features that Unity has. Then if you want to stay up to date with all the game dev news, then check out my Game Dev Report newsletter. I write it every single week with any interesting articles and game dev news that I come across every week. So if you want to continue learning, check out all those links in the description. Alright, thanks for watching and I'll see you next time.